In the previous video, we looked at a course overview. Now that you have an idea of what will be covered in the course, let's dive into Section 1. In this section, we will be looking at what is new in Hyper-V 2016, which is relevant to seasoned Hyper-V pros as well as beginners. Then we get back to basics by learning about the Hypervisor and its role. We move on to learn about oversubscription and overcommitment. The fun begins when we teach you how to download and install Hyper-V 2016, both as a bare metal hypervisor or as a role in Windows Server 2016. We then cover some basic virtualization architectures and go over what operating systems are supported as virtual machines or guests running in Hyper-V 2016. Now let's move on to the first video in this section. In this video, we will be looking at what's new in Hyper-V 2016. This is really intended for viewers that are already somewhat familiar with Hyper-V. For new viewers, we will be covering some of these topics later in the course. When the Hyper-V role is installed on a computer that uses the always-on, always-connected power model, you can now use this state. Discrete device assignment lets you give a virtual machine direct and exclusive access to some PCIe devices. Using a device in this way bypasses the Hyper-V stack and can result in faster performance. Host resource protection prevents a virtual machine from using more than its share of system resources. With hot add and remove for network adapters and memory, you can now add or remove network adapters and adjust memory while the virtual machine is running. The Hyper-V Manager now allows you to use different credentials to connect to other Windows servers, and you can manage earlier versions of Hyper-V running on Windows Server 2012, 2012 R2, Windows 8, 8.1, in addition to Windows Server 2016 and Windows 10. Integration services for Windows VMs now receives updates directly from Windows Update. This obviously doesn't apply to non-Windows virtual machines such as Linux. And Linux operating systems running on Generation 2 virtual machines can now boot with the Secure Boot option enabled, which prevents rootkits and other malware from infecting the bootloader. With nested virtualization, you can run Hyper-V on a virtual machine that is running on a Hyper-V. Not really recommended, but for some test environments it can be useful. New networking features include Remote Direct Memory Access, Switch Embedded Teaming or NIC teaming, Virtual Machine Multi-Queues, which improves networking performance, and quality of service for software-defined networks. Production Checkpoints allows you to take point-in-time snapshots of virtual machines that comply with support policies for production machines. This simply means that virtual machines will be snapshotted on a regular basis. With rolling Hyper-V cluster upgrades, you can add a Hyper-V 2016 host to a Windows Server 2012 R2 host cluster, so you can upgrade the cluster without any downtime. With Start Order Priority, you can set specific virtual machines to start first in the event they provide essential services that other VMs rely on. With Storage Quality of Service, you can now create storage QoS policies. Shielded virtual machines prevents untrustworthy administrators and malware from inspecting, tampering, or stealing data from the virtual machine. Everything is encrypted and the virtual machine must run on a known, healthy host as determined by a host guardian server. Virtual machine configuration files use a new format that is more efficient for reading and writing configuration data. Virtual machine config data uses a VMCX file extension, and runtime state data uses a VMRS file extension. The virtual machine configuration version simply says whether or not a VM can be run on both Hyper-V 2016 or Hyper-V 2012. Containers are all the rage right now, and now you can run Windows containers. A container is basically a virtual machine that runs a stripped-down, lightweight operating system. Windows PowerShell Direct combines PowerShell with VM Connect, It basically allows you to run Windows PowerShell commands in a virtual machine from the Hyper-V host. In this video, we looked at what is new in Hyper-V 2016. In the next video, we will step back to basics by learning what exactly a hypervisor is. In the previous video, we looked at what is new in Hyper-V 2016. Now let's take a minute and get an understanding of what a hypervisor is. In this video, we will take a look at what a hypervisor is. We will learn what Type 1 and Type 2 hypervisors are, and we will also take a look at a hybrid hypervisor and a new technology called containers. There is plenty of information out there on the internet for you to research, but I will try to give you some basic information. If you have experience with hypervisors, this will seem native to you. Wikipedia actually has a good definition of what a hypervisor is. A hypervisor, also known as a virtual machine monitor, is a piece of computer software, firmware, or hardware that creates and runs virtual machines. A computer on which a hypervisor is running, one or more virtual machines, is defined as the host machine. Each virtual machine is also called a guest machine. And as you may have correctly guessed, Hyper-V is a hypervisor. A hypervisor is essentially a stripped-down operating system designed to do one thing: manage virtual machines. Hypervisors have evolved over time, but there are three commonly known types of hypervisors. You will see the traditional server with an operating system on the left, such as a Windows Server. In the middle, you'll see Type 1 hypervisor, and that's also known as a bare metal hypervisor, because it is the only operating system installed onto the bare metal hardware or server. The Type 2 hypervisor is said to be such because it relies on or is dependent upon an initial operating system being loaded onto the server before the hypervisor can be installed and run. Examples of Type 1 hypervisors are VMware ESX, Xen Server, and KVM. Microsoft would like you to believe that Hyper-V is a Type 1 hypervisor for marketing purposes. However, the reality is you need to install Windows Server and then turn on or enable the Hyper-V service. So it can be argued that the Hyper-V is a Type 2 hypervisor. Another example of a Type 2 hypervisor would be VMware Workstation and Oracle's VirtualBox. Hypervisors are advancing in their technical prowess, and the lines between Type 2 and Type 1 are becoming more and more blurry as we hear about hypervisors gaining access to the underlying hardware through extensions or modifications to hardware and their APIs to allow the virtual machines or guests to bypass the hypervisor or operating system kernels and go straight to the hardware. These are being called hybrid hypervisors. You have undoubtedly heard about Docker. There is an emerging virtualization technology called containers, where an even more stripped-down operating system is run inside of an already stripped-down operating system. These containers are very lightweight and don't have to incur the burden of having to be controlled by a hypervisor. Some examples of containers are all of the Google Doc applications, Linux's vServer and LXC technology, and now you can run containers in Hyper-V. Now that you have an understanding of what a hypervisor is, let's talk briefly about oversubscription in the next video. In the previous video, we looked at some basic information to understand what a hypervisor is. Now let's take a minute to get an understanding of the concept of oversubscription. In this video, we will take a look at the concept of oversubscription, along with network oversubscription, memory oversubscription, storage oversubscription, and CPU oversubscription. Oversubscription is good and is the linchpin of virtualization. It allows you to make use of resources more effectively and efficiently. All of those idle CPUs of yesterday's architectures will now be put to good use. It is really brilliant if you think about it. If you have a traditional server with 24 CPU cores and only 4 or 8 of them are effectively used at any given time, Wouldn't you rather maximize the use of all CPUs to get the most out of your investment? Well, that is one of the benefits of virtualization, and this is possible with the concept of oversubscription. The term is often confused with overcommitment, and some say that semantically, overcommitment is bad because it implies that you are actually using more resources than you have on hand, and virtual machines will be thrashing as they contend for resources. Oversubscription says, I'm going to assign resources to virtual machines beyond what is physically available in the server, because I know that not all virtual machines will be using the physical infrastructure at the same time, and this is the beauty of virtualization, as it speaks directly to return on investment. Network oversubscription simply says that you can create virtual machines with network interfaces whose sum total capacity is greater than what would normally be supported in the traditional physical server. Keep in mind that when and where to do this depends on your workload or applications. Memory oversubscription allows you to allocate more memory to your virtual machines than is physically available on the server. Again, this depends on your workload or application. Storage oversubscription allows you to allocate more virtual storage than is physically available. Sometimes this is referred to as over-provisioning or also thin provisioning. CPU oversubscription allows you to assign virtual CPUs or vCPUs in numbers that exceed the number of physical CPU cores on the server. One thing to keep in mind with oversubscription is don't overdo it when assigning resources to virtual machines. However, you now have more resources available through oversubscription and can pack more virtual machines into a single server. Now that you have an understanding of oversubscription and how it applies to virtualization, let's move on. In the next video, the fun starts. We will show you how to download and install Hyper-V 2016. In the previous video, we looked at oversubscription. Now the fun begins as we show you how to download and install Hyper-V 2016. In this video, we are going to show you how to download and install Hyper-V 2016. To download Hyper-V 2016, you need to navigate to the Microsoft Technical Evaluation Center. I've created a bitmark for you on the screen for easy navigation. You can see here that I'm navigated to the Microsoft Tech Center, located Hyper-V 2016 evaluation, and have started to download it to my local hard drive. Now that you have a copy of the installation image, you will need to create a bootable USB stick. There are various tools and methods for creating a bootable USB stick using Windows, Linux, or Mac. Once you have the bootable USB stick created, you can begin the installation. You can see here I'm booting from my USB stick to install Hyper-V. There is the familiar window. We click through some options and start the installation. Agree to the license. Create a partition on the disk drive. And begin the installation. Depending on the speed of your server, installation could take a while, so we'll skip some of that and go straight to the part where Hyper-V starts to boot up. There are some administrative tasks we need to do. Just as we install Hyper-V, the first thing is to change the administrator password. Once that is done, we will boot into the initial CLI or command line style boot screen for Hyper-V. Remember, this installation that we're using is bare metal and does not have a GUI associated with it. So we will see a text-based type of menu appear in a few seconds. And here we are at the server configuration menu. One of the first things that we will do is change the computer name. Next, we will enable remote desktop so that I can contact the machine and log into it using Microsoft Remote Desktop Client. And finally, I will assign a static IP address because for any server, we know that we don't want to be using DHCP so that our IP address is floating around. We want to use a static IP address so that we can contact the server at the same IP address all of the time. Now you can see that our installation is complete, and it is quite simple. Now that you have an idea of how to download and install Hyper-V 2016, we can talk about some architecture and options in the next video. In the previous video, we discovered how to download and install Hyper-V 2016. In this video, we are going to take a look at some hypervisor architectures, some virtualization methods, and Hyper-V installation options. Let's take a look at some simplified architectures to help you understand what Hyper-V is doing. I've included a couple of other hypervisor architectures for comparison, and you will notice that they all do pretty much the same thing. VMware has its rings of privilege. The hypervisor runs in ring 0 and has the highest privileges. This is sometimes referred to as kernel mode or root mode. Higher level rings are where the virtual machines run, which consequently have lower privileges. The hypervisor has to have root-like privileges in order to effectively communicate with the underlying storage, memory, CPU, and networking hardware. So it therefore runs in ring 0. Xen Server has domains, such as DOM-U for virtual machines or user mode, and DOM-0 for the hypervisor or kernel mode. Similarly, Hyper-V has its partitions. The hypervisor runs in the parent partition, and the virtual machines run in the child partitions. The hypervisor is the operating system that all virtual machines must go through. Therefore, it has to have the highest privileges to get access to the underlying hardware. Here are some terms to help you understand how hypervisors do this. Full emulation was the first type of virtualization, meaning the hypervisor had to emulate all of the underlying hardware. This is an older technique and performance is not really that good. Paravirtualization allows the virtual machine to make API calls to the hypervisor to get access to the underlying hardware. Enlightened I/O is the Hyper-V term for paravirtualization. The virtual machines need to have the paravirtualization or Enlightened I/O drivers installed in order to take advantage of this. Hardware-assisted virtualization is a technique by hardware vendors, such as Intel and AMD, to improve performance of virtual machines operating in virtualized environments without having to use paravirtualization drivers. Hardware-assisted virtualization requires that these virtualization features of the hardware are enabled in BIOS. The use of both paravirtualized guests with hardware-assisted virtualization is called a hybrid approach and tends to offer the best performance. The Hyper-V 2016 evaluation image that we downloaded installs as a piece of software by itself and could be considered a bare metal version of the hypervisor. As such, it installs very lightweight, meaning it only contains the Windows hypervisor with drivers and virtualization components. This also means it does not have a GUI, it only has a command line interface. There are other ways of installing Hyper-V. If you choose to install the Windows Server Core operating system, you get the Windows Server, but you need to add or enable the Hyper-V server role. Server Core also does not have a GUI, only a command line interface. And of course, you can install the complete Windows Server with the desktop experience, which includes the full Windows Server with the GUI, and also here you need to add or enable the Hyper-V server role. Now that you have an understanding of the Hyper-V basic architecture and installation options, we will discuss virtual machines in the next video. In the previous video, we learned about some basic architecture and Hyper-V options. In this video, we will learn what a virtual machine is, also known as a guest operating system. We will take a brief look at the steps to create virtual machines, and then we will look at the supported virtual machines or guest operating systems for Hyper-V 2016. If you remember from a previous video, when you install the Hyper-V Hypervisor, it becomes the parent partition or root partition. All of the virtual machines run as guests in the child partitions. One parent can host multiple children or VMs and/or containers. The distinct difference between the hypervisor and the virtual machine is that the virtual machine does not have privileges to access the underlying hardware and must go through the hypervisor to get access to resources on the server. Virtual machines essentially run as abstracted physical computers within the hypervisor. The hypervisor presents a software interface of the physical hardware to the virtual machine. It is the job of the hypervisor to host, run, and monitor the virtual machines. Obviously, you can have many virtual machines running within a hypervisor, which could be running on a single server. Containers are libraries or processes that run within the hypervisor and don't have the extra overhead of a full-blown operating system. To create a virtual machine, you need to download the ISO image of the operating system and make sure that image is available to the Hyper-V manager. There is an option when you create the virtual machine to configure the CD or DVD drive to point to the ISO image so it can boot from it and perform an install. Once you have booted to the ISO image, you would perform an installation of that operating system the same way you would if you were installing from a physical CD or DVD onto a physical server. You can install virtually any type of operating system into a virtual machine. Virtual machines can be built to run servers, and the following Microsoft Server operating systems are supported as VMs in Hyper-V: Windows Server 2016, Windows Server 2012 and 2012 R2, Windows Server 2008 Service Pack 1 and 2, Windows Home Server 2011, Windows Small Business 2011, Windows Server 2013, Service Pack 2, and R2 Service Pack 2. Virtual machines can be built to run client operating systems, and the following Microsoft Windows software are supported: Windows 10, Windows 8 and 8.1, Windows 7 and 7 Service Pack 1, Windows Vista Service Pack 2, Windows XP Service Pack 3, Windows XP 64-bit Service Pack 2. You can even run non-Windows operating systems as VMs in Hyper-V. For example, Linux server OSs such as Red Hat Enterprise Linux or CentOS 5.x, 6.x, and 7.x, Debian 7.x and 8.x, Oracle Linux 6.x and 7.x, SUSE 11 and 12, Ubuntu 12, 14, 15, and 16, and FreeBSD 8.4, 9.x, and 10.x. In this section, we looked at a course overview, what's new in Hyper-V 2016, what a hypervisor is, the concept of oversubscription, how to download and install Hyper-V 2016, the architecture and options along with Hyper-V 2016, and virtual machines. Now that you have an understanding of where the virtual machines fit into the picture, let's move on to section 2 of this course. Welcome to the Learning Windows Server Hyper-V 2016 video course by Pact Publishing. My name is Craig Elrod, and I will be guiding you through this course. I have over 30 years of experience in the computer industry, a bachelor's degree in computer science, and a master's in business. I've held many positions in the computer industry and have authored books related to virtualization. I have hands-on experience with Hyper-V, VMware ESXi, XenServer, and Linux KVM. You can read more about me at the link on the screen. In this video, we will look at a course overview. To be more specific, we will be covering a section on getting started, which involves downloading and installing Hyper-V 2016. We will then look at Hyper-V management, which involves using Hyper-V Manager, as well as System Center Virtual Machine Manager. We will cover the complex subject of network virtualization, followed by a section on memory virtualization and CPU virtualization. Finally, we will cover storage virtualization, followed by some advanced topics. In Section 1, Getting Started, we will have a course overview and look at what is new in Hyper-V 2016. We will then look at what a hypervisor is and the concept of oversubscription. The fun begins when we learn how to download and install Hyper-V 2016. The Hyper-V 2016 technical preview does not require a license from Microsoft. After the installation, we will look at some basic hypervisor architectures and installation options. Hyper-V 2016 can be installed as a bare metal hypervisor, but it can also be installed from within Microsoft Server 2016 and added as a role. Finally, we will look at virtual machines, what they are, and what is supported. In Section 2, we look at Hyper-V management. You have to have a way to manage Hyper-V if you are going to add virtual machines and be able to configure all of the options. We will talk about how to manage virtual machines from both Hyper-V Manager as well as System Center Virtual Machine Manager. Then we will cover operating system support. In Section 3, we will learn about Hyper-V network virtualization. Networking becomes very interesting when multiple virtual machines start contending for the same internal networks and the externally facing network interface card. There are some new concepts to learn, such as external, internal, and private networks, direct access networks, and networks that use Windows network virtualization. We cover the performance topic of SR-IOV, followed by Hyper-V VLANs, policies, and load balancing. In Section 4, we will learn about Hyper-V memory virtualization. Memory management is nothing new to operating systems, however, it gets very interesting when multiple virtual machines are contending for the same memory resources in a finite physical server. How you allocate memory to a virtual machine and tweak it with certain memory techniques will determine how your virtual machine performs. First, we talk about memory virtualization and then show you how to configure it. We cover memory overhead, smart paging, and NUMA, followed by some statistics and performance monitoring. In Section 5, we will cover Hyper-V CPU virtualization and what it means to share CPU resources. We show you how to configure CPU virtualization, and then we also cover a couple of additional topics such as Enlightened I/O, affinity or pinning, and finally some statistics and performance monitoring. In Section 6, we look at Hyper-V storage virtualization. When virtualization meets with storage, the data center explodes. With networked storage, you can provide limitless amounts of storage to your servers. This, combined with the fact that storage devices can be external to the other compute, network, and memory resources, allowed for virtually no limits on virtual machines and storage. But with this bounding supply of storage comes a cost in performance as multiple virtual machines vie for the same data paths. There are some new concepts and features that have evolved to help improve performance of storage, and we will cover those in this section. More specifically, in this section, we cover storage virtualization and how to configure it. We talk about IOPS and quality of service, multipath I/O, shared versus dedicated storage, failover clustering, resilient file systems, live migration, and storage spaces. Finally, in Section 7, we take some time to cover some interesting and advanced topics, such as integrating your Hyper-V private cloud with Microsoft Azure public cloud. Then we talk about PowerShell and finally security. Before we move on to the next section, let's review the lab requirements for this course. If you look at the diagram, there are some servers that must be physical servers, such as the Hyper-V hosts and the domain controller. The management server and the SQL server can be physical or virtual machines. The layer 2 switches must be physical. However, instead of using 3 switches, you could easily use one physical switch and create VLANs for the 3 different networks that we will be working with. The hardware minimum requirements and the software downloads are listed in green bit links for quick reference to get you started quickly. You can refer to the Hyper-V 2016 minimum system requirements, but I wouldn't skimp on these for your Hyper-V servers. For example, the 2 servers I am using have 128 gigabytes of RAM, 12 terabytes of internal disk storage, 4 1 gigabit Ethernet ports, and 2 Intel Xeon 6-core processors. With hyperthreading turned on, that gives me 24 CPUs I can assign to virtual machines. We do use the Starwind software to create an iSCSI SAN out of our internal disks for Section 6, so you might want to grab this software ahead of time. Bit links are provided, and also again in Section 6 when we get there. Otherwise, if you have an iSCSI SAN available, that's great, but it's not required. It is optional. There is also a way to use fiber channel over Ethernet to connect your SAN, but again, this is optional. One final note on server types. Microsoft has released a new server type called Nano Server. This fits into the container technology that is talked about widely in the industry. Nano Server is an extremely stripped-down version of Windows Server intended for specific applications and definitely not suited to a full-blown Hyper-V implementation with all of the features that we need for this course. Our Hyper-V servers will be running as the server core type that doesn't include any noticeable GUI. The management server, SQL server, and domain controller will be full Windows Server data center editions with the desktop experience or GUI included. Hi, and welcome to Section 2. In this section, we will cover Hyper-V management. Specifically, we are going to talk about the Hyper-V Manager and then how to use it to manage virtual machines. We will also talk about managing resources using System Center Virtual Machine Manager, and finally some further discussion with regard to supported operating systems and the drivers needed to make virtual machines run well in Hyper-V. Before we go too much further into Section 2, we should call out some subtle differences between Hyper-V Manager and System Center Virtual Machine Manager. Hyper-V Manager is designed to manage single Hyper-V hosts in small deployments needing simple management. Hyper-V Manager executes commands directly on the Hyper-V host. Virtual Machine Manager is designed to be a more robust management solution, and it includes features that Hyper-V Manager doesn't have, including the ability to support multi-tenancy. For example, you can create multi-tenant networks, connect to the Azure public cloud, and support up to 1,000 Hyper-V hosts and 25,000 virtual machines. VMM can connect to a multi-vendor environment that includes Hyper-V, VMware ESX, and others. VMware uses a SQL database and executes commands in jobs, so it is highly scalable and designed for large deployments. Now we move on to the first video of this section that deals with the Hyper-V Manager. After watching this video, you will know how to log into the Windows Server, install Hyper-V Manager as both a feature or as part of the Hyper-V role. There are 2 ways to install the Hyper-V Manager. either as a feature on its own or also as a feature that's installed along with the Hyper-V role. If you remember back to the previous section, we mentioned that you can install Hyper-V as a role on Windows Server, and that is specifically where the Hyper-V Manager would get installed along with the Hyper-V role. Hyper-V Manager runs on Windows Server. First, we need to create a separate Windows Server 2016 installation on a separate computer from the Hyper-V server. Hyper-V Manager needs to run on a computer that is external from Hyper-V. In other words, I have two servers running now, as you can see from the network diagram. I did take some extra time to install a Windows Server 2016. One server has the Hyper-V bare metal installation on it, on the left, and the other server has Windows Server 2016 installed on it. If you take a look at the network diagram, I also have the Microsoft RDP client to connect to the Windows Server 2016. Once I am logged in, I will be able to install the Hyper-V Manager as a feature by navigating to the Start menu, Launch Server Manager, Add Roles and Features, Role-based or feature-based installation, select a server, click on Roles, and I don't select anything in Roles, I go straight to Features. Then I open Remote Server Administration Tools, then I open Role Administration Tools and select Hyper-V Management Tools. Then I click Next and Install, and that will install the Hyper-V Manager as a feature on this server. You can also install Hyper-V Manager along with the Hyper-V role on a Windows server by navigating to the Start menu, Launch Server Manager, Add Roles and Features, Role-based or Feature-based, select a server, select Roles, select the Hyper-V role, and then a window pops up asking you to add the Hyper-V Manager. Click Add Features, Next, and Install. Before we move on, I wanted to cover a valuable tip that you're going to need as you move forward. Microsoft Edge is the new web browser from Microsoft. When you try to launch it, you might get an error saying this app can't open. Microsoft Edge can't be opened using the built-in administrator account. There is a way to make it work, and the fix is outlined here. Simply enable admin approval mode for the built-in administrator account in User Account Control, set a registry editor value, and restart the computer. It will work from that point forward. In this video, you learned how to install the Hyper-V Manager either as a feature or along with the Hyper-V role. In the next video, we will learn how to manage virtual machines with Hyper-V Manager. In the previous video, we learned about Hyper-V Manager. In this video, we will learn how to create and manage virtual machines. After watching this video, you will know how to launch Hyper-V Manager and connect it to the Hyper-V Hypervisor, at which point you can then create and manage virtual machines running guest operating systems. The Hyper-V Hypervisor hosts the virtual machines, and the Hyper-V Manager manages them. Before you can manage VMs, you need to learn how to connect Hyper-V Manager to the Hyper-V Hypervisor, and then create virtual machines. First, we need to connect the Hyper-V Manager running on the Windows server to Hyper-V Hypervisor. A quick note about using these servers in the workgroup mode. In order for Hyper-V Manager to connect to Hyper-V Hypervisor when they are running in a workgroup, some changes need to be made, and that is what the bit link on the screen refers to. If you are running the servers in a domain, these mods are not necessary. From the Windows Server 2016 Start menu, you select Administrator Tools and Hyper-V Manager. In the upper right corner, you click on Connect to Server. You enter the Hyper-V server name or IP address and then click OK. You are now connected to the Hyper-V Hypervisor from the Hyper-V Manager and can now create and manage virtual machines. Once connected to Hyper-V, you create a virtual machine under the Action New Virtual Machine menu. This launches you into the Virtual Machine Creation Wizard. Give your virtual machine a name. It's also good to know the difference between Generation 1 and Generation 2 VMs, so let me explain those briefly. Generation 1 VMs are good for 32-bit operating systems and older operating systems. These are also useful in using older versions of Hyper-V. Generation 2 virtual machines are for 64-bit operating systems. They boot faster, use less emulated hardware devices, which means better performance, and can integrate with Microsoft Azure. Also note that the Gen 2 VMs work with the latest releases of Hyper-V only, so if you will be moving VMs to older Hyper-V versions, this could be an issue. Give it some memory. In our case, we'll give it 4 gigs to start up, and we'll use dynamic memory. For networking, we don't have any adapters configured yet, so we'll leave that disconnected, and we can change that later. For the hard disk, we will accept the defaults, and we will install our guest operating system in the next step. So we select Finish, and we've created our first virtual machine in Hyper-V. Before we install the guest operating system, we need to copy the guest operating system installation image up to the Hyper-V server. And before we do that, we need to create a shared drive on the Hyper-V server to copy it to. From the Windows server, we'll click on Start, select Server Manager, then we'll select Hyper-V, right-click on Hyper-V, select Computer Management, Shared Folders and Shares, and we'll do a right-click in the middle pane and say New Share. On the Hyper-V server, we will create a shared drive called C:\ISOs, and we'll give it administrators that have full access, and all other users will have read-only access. Next, you need to download the guest operating system ISO image to the Windows server, and then copy that guest operating system image over to the Hyper-V server shared drive. From the Windows server, launch the File Explorer, click on Network, navigate to the Hyper-V server, open the ISO directory, then open another File Explorer, click on Network and open up the Windows server, open the ISOs directory, and take the file that you downloaded, the guest operating system ISO image, and copy it over to the Hyper-V server shared drive. Once you've downloaded the installation image and copied it up to the Hyper-V server, you then need to open the Hyper-V Manager and attach the ISO image to the CD/DVD controller for the virtual machine. This way, it looks like you are just installing the operating system from a CD as if it were attached to the machine. To do this, you go to the Windows Server Start menu, select Administrative Tools, and click on Hyper-V Manager. From your VM, you go to Settings and Add DVD Drive. For Image File, you then select the ISO image that you had copied up to the Hyper-V shared drive. Apply, click on OK, move the DVD drive up to the top of the boot order under Settings, and then start your virtual machine. and you will begin to install the Windows operating system into this virtual machine. When you finish the installation, you will then see the Windows operating system running as your first virtual machine inside of Hyper-V. Once the virtual machine has been created and the operating system successfully installed, you can then connect to the virtual machine. To do this, from the Hyper-V Manager, you select the virtual machine, right-click, and select Connect. You're now connected to your virtual machine. In this video, you learned how to connect Hyper-V Manager to Hyper-V Server so you could create and manage virtual machines. You learned how to create your first virtual machine and install a guest operating system into it. Once the installation was successful, you learned how to connect to the virtual machine. In this case, it was running Windows 8.1. In the next video, we will learn about the topic of resource pools and how to manage resources with System Center Virtual Machine Manager. In the previous video, we learned about managing virtual machines in Hyper-V Manager. In this video, we will learn about managing resources with System Center Virtual Machine Manager. After watching this video, you will know about resource pools and System Center Virtual Machine Manager. In order to run Virtual Machine Manager, you need to be operating within a domain, so we will show you how to join your Hyper-V server into a domain. Please note, this assumes you have a domain controller already installed and ready to work with. In our example, we have taken our Windows Server 2016 and turned it into a domain controller. Another requirement of Virtual Machine Manager is to have a SQL server installed. We will also introduce PowerShell as it becomes an important tool for use with Hyper-V. Other hypervisors have the concept of resource pools, but each vendor implements them differently. The concept of resource pools is pretty simple, but let's review. In the image you see on the left a swimmer who you can think of as a workload or application running in a VM, and the VM running on the server, a single pool of resources. If it's a large workload, eventually it will become too big for the single server and exhaust the physical resources. If you combined several smaller pools into one large pool, looking at the image on the right, the applications and workload would have more room to run and grow, providing more flexibility and power. Many and different workloads can run in the pool without being starved for resources, and without starving out other applications and workloads. Everything we've done up to now has been done in a work group, including the Hyper-V Server and Hyper-V Manager. That was good practice to get you started and maybe build out a small set of Hyper-V servers and virtual machines. However, if you're going to do anything beyond that, you will need to put all of your machines into a domain. Joining Hyper-V to a domain is fairly simple. Please note that you do need to build an extra server and install Active Directory domain services on it. Joining your Hyper-V server to a domain is a requirement if you're going to run System Center Virtual Machine Manager. If you follow the demo on the screen, you can see I am logged into my Hyper-V server running in a workgroup. I select option 1 to join a domain. If you've joined computers to a domain before, the process is the same, however you notice that it is text-based because there is no GUI on the Hyper-V server. In addition to the domain, System Center Virtual Machine Manager requires a SQL database, so make sure you have that additional server built, and the instance name needs to be Virtual Manager DB. Once you have a domain controller and a SQL server built, you can download and install System Center Virtual Machine Manager. The remainder of this video will show you the installation steps for Virtual Machine Manager and how to add a resource. After you have unpacked the download, run setup exe as administrator by right-clicking on the setup file. Follow the installation prompts, and in our case we use the default values and a domain account for the service management. Once you have VMM successfully installed, you will find it under the Start menu in Applications. You will notice that I have installed VMM on the same Windows server that I have Hyper-V Manager installed on. Navigate to Applications, launch the Virtual Machine Manager console, and connect. Once VMM Manager is open, you'll see many options. If we select Fabric in the lower left-hand navigation and then select Add Resources at the top, you will see that we can add a Hyper-V host. Follow the connection prompts. Discovery scope can be a little finicky. Enter your Hyper-V server fully qualified domain name and click Next. If you get an error message, just do a refresh and your server might appear. If your server doesn't appear, then you may have other problems that need investigation. Under Host Settings, we can add a directory to store the virtual machines in. Although we are adding the directory to the C drive of the Hyper-V server here, you would not want to do this in production, and this would cause resource contention. You actually should place this directory on a different disk medium so as not to affect performance. Essentially, you don't want Hyper-V and virtual machines running on the same disk. Once you have added your Hyper-V host, you will see a job running as the Hyper-V server is added to the set of resources. You will also notice that VMM reaches out to the Hyper-V server and installs an agent, among other things. Now you see the Hyper-V server listed among the resources in Virtual Machine Manager. Congratulations, you have just created your first resource pool. If you take some time to look around VMM, you will notice all of the other resource settings available. In this video, you learned about resource pools and System Center Virtual Machine Manager. In the next video, we will learn about virtual machine operating system support. In the previous video, we learned about managing resources with Virtual Machine Manager. In this next video, we will learn about supported operating systems and what that means. After watching this video, you will know that Windows operating systems are supported for running in virtual machines, and the integration services drivers are automatically installed when you create the virtual machine. For all other operating systems, you need to install the integration services drivers manually if they are available. We touched on this briefly in Section 1. The following Windows operating systems are natively supported as virtual machines in Hyper-V. If you remember back in Section 1, we talked about para-virtualization drivers and APIs that allow a virtual machine to work better in an hypervisor. In VMware and Xen, they are called tools, and they have to be installed on the virtual machine. In Hyper-V, they are called integration services. And as you can see from the on-screen demo, integration services is automatically installed and enabled on Windows operating systems. In older Windows VMs, you need to mount the vmguest.iso image and install integration services manually. If you can't locate the vmguest.iso image, you can simply copy it from a previous version of Windows, and that will work also. Hyper-V Integration Services is that hook or bundled set of software drivers that improve integration and performance between the Hyper-V host and the virtual machine. Integration services come pre-installed on most virtual machine operating systems. OS shutdown simply means you can shut down the virtual machine from one of the virtual machine managers, that being either Hyper-V Manager or System Center Virtual Machine Manager. Time sync synchronizes the time on the host with your virtual machine. Data exchange provides sharing of data between the Hyper-V host and the virtual machine. Heartbeats allow you to view whether or not a VM is alive from a management interface. Backups and snapshots allow a virtual machine to be backed up or snapshotted while it is running. Guest services is oddly named. It essentially allows you to copy data to the virtual machine without using a network connection. You can run Linux virtual machines in Microsoft Hyper-V, and the list of supported versions just keeps growing. Installing the integration services for Linux is a manual process. First, you must download the package in either tar format or ISO format, and then you install the integration services software. The PDF file in the download shows you how to install integration services using either method. In this section, you learned about Hyper-V Manager, how to install it and connect it to the Hyper-V server. You also learned about System Center Virtual Machine Manager and how it is different from Hyper-V Manager. You learned how to create a virtual machine and which operating systems are supported as virtual machines. You also learned about the special drivers for Hyper-V called integration services. You learned about resource pools as Microsoft Hyper-V is concerned, and that you can manage resources using the System Center Virtual Machine Manager. In the next section, we will learn about Hyper-V network virtualization. Hi, and welcome to Section 3. In this section, we will cover Hyper-V network virtualization, types of virtual networks, and types of virtual switches, followed by examples and demos of these networks. I want you to notice that networking is different and simpler in Hyper-V Manager than it is in Virtual Machine Manager. We will spend some time covering these differences so you know them. If there is anything you get out of this course, this is the part I want you to learn. Then we will cover Single Root I/O Virtualization, or SRIOV. Then we will cover VLANs, policies, and network load balancing. Now we move on to the first video of this section that deals with Hyper-V network virtualization. After watching this video, you will understand what network virtualization is and the different types of virtual networks and virtual switches. Once Hyper-V is installed and virtual machines are created, you need to provide a way for them to talk. Since there are no physical network interface cards in the VMs, you need virtual networking. First, we will explain what network virtualization is. Then we will go over the different types of virtual networks and switches and their purpose as they apply to Hyper-V Network Manager. Then we will go over the different types of virtual networks and switches and their purpose as they apply to System Center Virtual Machine Manager. Hyper-V Network Virtualization provides virtual networks to virtual machines in the same way that Server Virtualization, or the Hypervisor, provides virtual machines to the operating system. Network virtualization decouples virtual networks from the physical network infrastructure and removes the constraints of VLAN and hierarchical IP address assignment from virtual machine provisioning. In traditional servers, you had physical network adapters, and this was quite limiting. Network virtualization abstracts the underlying hardware, that is the physical network adapters, and allows you to create multiple virtual and logical networks. This flexibility allows you to assign multiple virtual NICs to virtual machines and adjust the scale and workloads across a pool of resources. In Hyper-V Manager, there are three types of virtual networks. External virtual networks are used to provide virtual machines with access to a physical network to communicate with externally located servers and clients. The external virtual network binds to a physical network adapter. In an external network, virtual machines on the same physical server can still communicate with each other internally, if you will, but they can also communicate with entities outside of the physical Hyper-V server. This network is and can also be used by the management operating system or the Hyper-V hypervisor. Internal virtual networks are used to allow communication between virtual machines on the same Hyper-V server. The internal network does not bind to a physical network adapter. Private virtual networks are used to allow communication only between the virtual machines on the same Hyper-V server. A private virtual network does not bind to a physical network adapter. If you are going to configure virtual networking from System Center Virtual Machine Manager, there are a few more concepts you need to learn. VMM is used to manage resource pools, if you will, so these concepts apply when you want to provide virtual networking at grand scale. System Center Virtual Machine Manager, or VMM, provides the various architectural components to enable highly complex network environments to be configured, including logical networks, logical switches, virtual networks, and switch port profiles. It will be daunting at first, so I will try to keep it simple to understand. A host group is a grouping or pool of physical Hyper-V servers that allows you to assign networking models to a pool of Hyper-V servers. VMM uses the concept of logical networks and sites to group and manage resources. A logical network is a user-defined grouping of IP subnets, IP address pools, and VLANs that are abstracted from the physical hardware. A virtual machine network, or a VM network, is created because it is what is used to connect the virtual network adapter inside the virtual machine to the network. Using VMM to create and manage virtual networking is really what allows you to scale up and out, because it allows you to create multi-tenant networks in addition to single-tenant networks. There is a subtle nuance in virtual networking with VMM, and you have to look out for it when creating the logical network. There is a checkbox for a direct access network and a checkbox for a network virtualization network. You can select one or the other, or both if you only have one direct access network defined. A direct access network is the simplest form of a network where VM networks do not need to be isolated from each other and require direct access to the physical infrastructure. The VM network simply passes through communication from the virtual machine directly to the infrastructure. A network that uses network virtualization is what we'd hope to achieve with virtualization, and was conceived as sort of the service provider toolset to create multiple networks for multiple tenants that span multiple physical Hyper-V servers. It separates and abstracts logical networks, hence physical networks, from virtual machines. Each virtual machine network is isolated from other virtual machine networks. When you use network virtualization, you have chosen to work with an IP addressing model that identifies virtual machine IP addresses and subnets with what is termed customer address space, and inter-VM networking space as provider address space. Customer address space and provider address space become important because CA space is what is used for the IP addresses inside of the virtual machines, and it is the IP address that the virtual machine sees and uses. Provider address space is used on the virtual switch or logical switch to route communication between VM networks. It does this using Network Virtualization Generic Routing Encapsulation, or NVGRE. Provider IP addresses are used for switch-to-switch communication. Let's dive a little deeper and cover some additional concepts you will need to know when using network virtualization. Windows Virtualization, or WNV, is the module in Hyper-V that provides the components to enable network virtualization. Virtual machines that use the same IP subnet prefix run in what is called the virtual subnet, which is identified by the virtual subnet ID, or VSID. Hyper-V network virtualization uses VSIDs to separate virtual machine communications. With VSID, you can have multiple virtual subnets running in one logical network. VSIDs are more powerful than VLANs because VLAN IDs stop at 4096. VSIDs range from 4096 all the way up to 16,777,214. That means 16 million virtual subnets can be hosted on a logical network. The VSID is similar to the VLAN ID, however, the VLAN ID cannot be used with Hyper-V network virtualization. Instead, you must use the VSID. You cannot assign the VLAN ID to a virtual machine if it is already configured with a VSID, and vice versa. Note also that the vSID is assigned to the virtual network adapter of a virtual machine. The routing domain ID, or RDID, is a routing domain boundary in which virtual machines can communicate with each other, but cannot talk to virtual machines running in another RDID. The RDID provides isolation between customer virtual machines and is a requirement in Hyper-V network virtualization. The VM network is the logical network boundary created for virtual machines participating in the Hyper-V network virtualization. A VM network can consist of multiple virtual subnets. Virtual machines in the same virtual subnet must use the same IP subnet prefix. Similarly, all virtual machines in a virtual subnet must use the same vSID so that they can belong to the same virtual subnet. You can have multiple virtual subnets created, but the virtual machines running in these virtual subnets must not overlap. Each VM network has a routing domain ID which identifies the VM network. Once again, the PA space is responsible for handling the virtual machine traffic across Hyper-V hosts. It is assigned to the physical network adapter of the external virtual switch. The provider address looks for inbound and outbound traffic for customer virtual machines, and then allows virtual machines to communicate at the physical layer. The CA space belongs to virtual machines participating in the Hyper-V network virtualization. The customer address is the IP address assigned to the virtual machine. The lookup table is used by the Windows Network Virtualization module to look for the destination CA IP address on the local or remote Hyper-V host. Without the lookup table, it wouldn't be possible for the WNV module to reach out to the virtual machines that are running on either the local or remote Hyper-V hosts. In other words, the Hyper-V host must have knowledge of all the virtual machines that are participating in Hyper-V network virtualization. Network Virtualization Generic Routing Encapsulation, or NVGRE, uses the generic routing encapsulation method to perform encapsulation and decapsulation on incoming and outgoing packets. Now let's talk about virtual switches in Hyper-V. The Hyper-V virtual switch is a software-based Layer 2 Ethernet network switch that is available in Hyper-V Manager and Virtual Machine Manager when you install the Hyper-V server role onto the Hyper-V server. The switch includes programmatically managed and extensible capabilities to connect virtual machines to both virtual networks and the physical network across physical resources. The standard switch is the regular Hyper-V virtual switch, and the configuration matches the external, internal, private networking paradigm that you see in Hyper-V Manager. Standard switches can be created and assigned in either Hyper-V Manager or Virtual Machine Manager. The caveat is this type of switch needs to be assigned to a physical network adapter on each Hyper-V host individually, which can be time-consuming. The logical switch goes beyond the standard switch and includes virtual switch extensions and uplink port profiles which define the network adapters used by the Hyper-V virtual switch. When you want to really scale and provide multi-tenant networks running across the same physical infrastructure, you need to use the logical switch. Port profiles specify which logical networks can connect through a specific physical network adapter. When you create a port profile and port classification, you add them to the logical switch. Port profiles and port classifications provide support for bandwidth management and quality of service. The logical switch or virtual switch is then applied to a network adapter in Hyper-V Server. In this video, you learned what virtual networking is and the different types of virtual networks and virtual switches for use in Hyper-V. You also learned the differences between Hyper-V Manager and Virtual Machine Manager with regard to virtual networks and virtual switches. Before we move on, keep in mind that if you're just building a simple lab, proof of concept, or small data center, then you will do just fine with Hyper-V Manager or VMM, creating basic external, internal, or private networks. If you are going to need complex networks running across the same switch fabric, using the same IP address space, or are venturing into the multi-tenant model, then you could proceed into using System Center Virtual Machine Manager and Logical Networking, along with Windows Network Virtualization. In the next video, we will show some examples and demonstrations of network types and switches in Hyper-V Manager. In the previous video, we learned about network virtualization and the different types of virtual networks. After watching this video, you will understand through examples and demos how networking works in Hyper-V as seen through the eyes of Hyper-V Manager. First, we will show an example of an external network and virtual switch using the standard switch in Hyper-V Manager. Then we will show an example of an internal network and switch using the standard switch in Hyper-V Manager. A private network is conceptually the same as an internal network, however, there is no hypervisor access to this network. The Hyper-V virtual switch is the software-defined networking piece or software-based switch that performs the same functions as a physical switch. You connect the virtual network adapters in the virtual machines to the virtual switch to provide communication for the virtual machines. The type of virtual switches align with the types of virtual networks we covered in the previous video. If you look at our diagram from the last video, you can see there are three basic types of virtual switches or networks that you can attach the virtual network adapter to. From the Hyper-V Manager, the external switch connects to a physical network adapter on the Hyper-V host. This is useful for obvious reasons of connecting VMs to the Internet and to other VMs on other Hyper-V hosts. The internal switch connects internally and is only used for communication inside of the Hyper-V server, amongst the hypervisor and virtual machines. The private switch connects only VMs internally and doesn't provide for hypervisor communication. Internal and private switches are really best for when you want to hide or isolate your network communication inside of the Hyper-V host. Creating virtual networks and virtual switches inside of Hyper-V Manager is very straightforward. From Hyper-V Manager, select the Hyper-V host and then click on Virtual Switch Manager in the right-hand navigation pane. Here is where you create external, internal, or private virtual switches or networks and bind the external networks to physical network adapters. You can see a demo of our external virtual switches working when I have a virtual machine created on each of the Hyper-V hosts. These virtual machines have a network adapter that is configured to connect to the external virtual switch on each Hyper-V host. Each network adapter on each Hyper-V host is connected to an external Ethernet switch, and a quick ping test across the network verifies connectivity. We can verify our internal network is working by taking two virtual machines on the same Hyper-V host and create network adapters configured for the internal network. We used static IP addresses for the demo, and a quick ping test verifies connectivity on the internal virtual switch. In this video, you learned about the external, internal, and private types of virtual networks for use in Hyper-V, and learned how to create and manage them using the Hyper-V Manager. In the next video, we will learn about the direct access virtual network as seen through the eyes of System Center Virtual Machine Manager. In the previous video, we learned about external, internal, and private networks in Hyper-V Manager. After watching this video, you will understand through examples and demos how a direct access virtual network works in Hyper-V, as seen through the eyes of System Center Virtual Machine Manager. Now that you have an understanding of the different virtual networks in Hyper-V as seen through the eyes of Hyper-V Manager, we will shift gears and learn about the direct access virtual network as seen through the eyes of System Center Virtual Machine Manager, or VMM. First, we will show all the steps necessary to create a direct access network in VMM. We will review a direct access network model and see what it looks like, and review a network diagram of how this would look in our lab. Then we will show an example of how to create a direct access virtual network using the logical network and logical switch in Virtual Machine Manager. We will connect two different Hyper-V hosts to the direct access network, create some virtual machines, and ping across the network. VMM uses the concept of logical networks to group and manage resources. A logical network is a user-defined grouping of IP subnets, IP address pools, and VLANs that are abstracted from the physical hardware. To create a direct access network in VMM, you need to follow these steps in order. First, you create a logical network, and here is where that little nuance is that we mentioned in the beginning of this section. When you create a logical network, you need to specifically tell it that it will be used for a direct access type of network. You will assign the logical network to your host group that contains the Hyper-V servers, and you will create a network site that contains IP subnet definitions. By the way, you can have multiple sites and IP subnets within a logical network. Next, you will create some switch port profiles for the uplink connection and for the virtual port connection. Then you will create a virtual switch with a virtual network adapter. Next, you create a virtual machine network to attach the virtual machines to. However, in the settings of VMM, we have set it to automatically create VM networks, so this VM network is created automatically for us. Finally, we create a virtual switch that uses the logical switch, and we point that to the Hyper-V host's physical network adapter. Now we can add a network adapter to existing virtual machines and connect it to the logical network. Inside the virtual machine, you can use either static or DHCP for the IP addresses, if you have a DHCP server on the network. If you look at the logical network model on Microsoft's website for a direct access network, you can see that you need to create the logical network, then create a virtual machine network and attach it to the logical network. You also see that you can add multiple servers to a host group. A logical network is a grouping of one or more virtual networks that contain IP subnets and address pools. If you look at the network diagram, you can see we have added another virtualization server running Hyper-V. We created a host group and put both Hyper-V servers into that host group, so that our networking configurations will apply to both servers in the pool or host group. At this point, we can create a logical network, create some IP subnets, and assign them to the hosts or Hyper-V servers in the pool. Now, let's step through an example of the configuration of the direct access network. The first thing we will do in VMM is navigate to Fabric Networking in the left-hand navigation frame and create our first logical network. And in this section, here is where that nuance we've been talking about occurs. We need to be sure to click the checkbox next to Direct Access Network. In the logical network, you will create a network site that contains IP subnet definitions and attach it to the host group so it can be applied to all Hyper-V servers in that group. Also, you remember us talking about how the virtual machine network is automatically created when the logical network is created. You can see that under the VM subnet section. Next, you create port profiles, one for the uplink to the physical connection and one for the virtual connection to the virtual machines from the logical switch. You also should create port classifications while you are here. Next, you create a logical switch. Here is where you would also connect third-party extensions, and this is where you connect port profiles, port classifications, and the Hyper-V virtual network adapter. Now we go into each Hyper-V host and connect the logical network to the physical adapter. We repeat this on each Hyper-V server in the host group. Next, we go into each Hyper-V host and select the Virtual Switches Configuration tab and connect the virtual switch to each Hyper-V host. We repeat this procedure on each Hyper-V server in the host group. You will notice that this is where we connect the logical switch and virtual switch to the physical adapter in the Hyper-V server. Since we've created this logical switch and virtual switch in the previous sections, we can apply that same setting to both Hyper-V hosts, and you can see that we're doing that here. And now for the real test. We can go into a virtual machine running on each Hyper-V server and add a network adapter and connect it to the logical network and logical switch we created. Then we go into the settings in the virtual machine and add a network adapter and connect it to the logical network and logical switch. We repeat this on some static IP addresses for each virtual machine. Both VMs are on the 10.0.0.0 network. The VM on Hyper-V host Hyper16 has an IP address of .28, while the VM on the other Hyper-V host Hyper162 has an IP address of .133. A quick ping test shows that these hosts can communicate across the direct access network. The virtual machines work with DHCP as well, and you can see I have installed a virtual machine to act as a dedicated DHCP server and have configured one of my VMs to receive a DHCP IP address. A quick ping test shows that this is working as well across the direct access network. In this video, you learned about the direct access network model and how to create and manage it using System Center Virtual Machine Manager. In the next video, we will learn about the Windows Network Virtualization module and how to use the technology of network virtualization using System Center Virtual Machine Manager. In the previous video, we learned about the direct access network in Virtual Machine Manager. After watching this video, you will understand through examples and demos how Windows Network Virtualization and Hyper-V Network Virtualization works as seen through the eyes of System Center Virtual Machine Manager. So far, you've learned about the types of networks you can use with Hyper-V Manager and the direct access network model in Virtual Machine Manager. We will shift gears once again and dive into a powerful yet complex topic: how to use network virtualization through System Center Virtual Machine Manager, or VMM. First, we will show all of the steps necessary to create a network that uses network virtualization in Virtual Machine Manager. We will review what a network virtualization model looks like and review a network diagram of how this would look in our lab. Then we will show an example of how to create a network with Windows Network Virtualization using the logical network and logical switch in Virtual Machine Manager. We will then connect two different Hyper-V hosts to the virtualized network, create some VMs, and ping across the network. If you look at the logical network model on Microsoft's website for networks created with network virtualization, you can see that you need to create the logical network, and then create a virtual machine network and attach it to the logical network. The key thing to notice is that with network virtualization, you are now working with a completely different networking paradigm. one that was designed for service providers or hosting providers. Namely, you can see that you now need to account for and configure two networks: the CA space where virtual machines live and the PA space where the NVGRE connections for switch-to-switch communication lives. And again, you can see that you can add multiple servers to a host group and use that to assign logical networks and VM networks to physical resources. With network virtualization, you can have multiple VM networks per logical network, and you can have multiple IP subnets per VM network. If you look at the network diagram containing the Hyper-V servers we've been using, we have designed a network that uses Windows Network Virtualization and Hyper-V Network Virtualization. At this point, we will create a logical network, number 2, and have a VM network using customer IP address space 10.2.0.0 that spans Hyper-V hosts and that is tunneled through the provider address IP space 99.99.99.0. To create a network that uses network virtualization in VMM, you need to follow these steps in order. The steps are similar as before, but with some added steps and things to look out for. The key thing to notice is that you are now creating two networks, one for the virtual machines called CA space, or customer address space, and one for the NVGRE tunnel called PA space, or provider address space. Again, VMM uses the concept of logical networks to group and manage resources. Now let's step through the configuration of the virtualization network. The first thing we will do in VMM is turn off the automatic creation of VM networks. We need to be able to create these on our own. Next, we will navigate to Fabric, Networking in the left-hand navigation frame and create a logical network number 2. And here is that nuance we've been talking about. Be sure to click the box next to Network Virtualization. In the logical network, you will add a network site that contains IP subnet definitions and attach it to the host group, so it can be applied to all Hyper-V servers in that group. And you will notice here that we are configuring an IP subnet for our provider address space on this logical network. Next, you create port profiles, one for the uplink to the physical connection and one for the virtual connection to the VMs from the logical switch. You should also create port classifications while you are there. Next, you create a logical switch, and here is where you would also connect third-party extensions. This is where you create connection port profiles, port classifications, and Hyper-V virtual network adapters. You will notice that this is where we attach virtual ports, and this is also where we attach our uplink port profiles. Next, we will create a virtual machine network to attach virtual machines to for the CA IP address space, or virtual machine IP address space 10.2.0.0. We will connect it to the logical network we created and make sure we have selected to use isolation in this network. Here we specify that we will be using the 10.2.0.0 subnet. Next, we create IP pools for the CA space and PA space. You can tell that this is the IP pool that hands out IP addresses using DHCP because the settings look very similar to DHCP settings. The IP pool for the CA space is created on the VM network, and the IP pool for the PA space is created on the logical network. An important caveat here, make sure you do not use the .1 IP address, as this is reserved for the default gateway in the network. In fact, it's good practice not to use the lower numbers in the IP address space. You might need these lower numbers for future consideration of IP addresses. Next, we create a VM network specifically for connecting the CA network space to the PA network space, and this one does not use isolation. Next, we go into each Hyper-V host and connect the logical network to the physical adapter. You will notice also that this is where we create a virtual switch and attach it to the logical switch that we created earlier. Next, we go into our virtual machines and add a network adapter and attach it to that CA VM network. We repeat this process for all of the Hyper-V hosts and all of the virtual machines that we want to connect in this network. This is also useful for when you create new VMs. These networks will be available for assignment. And now for the real test. We can go into a virtual machine running on Hyper-V server, add a network adapter, and connect it to the logical network and logical switch we've created. Then we can go into the setting on the virtual machine, add a network adapter, and connect it to the logical network and logical switch. We repeat this on the other Hyper-V server for another VM on that host. Both VMs are on the 10.2.0.0 network, and the VMs on the Hyper-V host Hyper16 have been given IP addresses from IP pool 10.2.0.100 through .120. And the VMs on Hyper-V host Hyper162 have also been given IP addresses from the same IP pool. If we log into each Hyper-V host, we can validate the PA IP addresses have been assigned to the switch with the get net virtualization provider address PowerShell command. Then we can ping the local PA IP address and the remote PA IP address using the ping-p command. Doing this will ensure that our NVGRE tunnel between the Hyper-V hosts is properly set up. We do this on both Hyper-V servers to validate the NVGRE tunnel is up. Next, we connect to the virtual machines themselves, and a quick ping test shows that VMs on the Hyper16 host can ping VMs on the Hyper162 host, and they're on the same network. The traffic from the VMs on Hyper16 is encapsulated in NVGRE and sent out on the physical wire across to the Hyper162 host, where it is de-encapsulated and sent on to the VMs that are on the same 10.2.0.0 network. In this video, you learned about Windows Network Virtualization and Hyper-V Network Virtualization, and how to create and manage virtualized networks using System Center Virtual Machine Manager. In the next video, we will learn about Single Root I/O Virtualization, or SRIOV. In the previous video, we learned about Windows Network Virtualization and Hyper-V Network Virtualization within Virtual Machine Manager. After watching this video, you will understand what SRIOV is, how it works, and when to use it. You will also understand where to enable it in both Hyper-V Manager and System Center Virtual Machine Manager. So far, you've learned about the types of networks you can use with Hyper-V Manager, the direct access network model, and network virtualization models in Virtual Machine Manager. With those, you should have a solid foundation on basic networking for Hyper-V to build on top of. The next building block we will cover is called Single Root I/O Virtualization, or SRIOV, as it is known. First, we will show you what SRIOV stands for, what it means, and how it got started, and when you should use it. Next, we will review how to turn it on in Hyper-V Manager, and finally, we will show you how to enable SRIOV in System Center Virtual Machine Manager. The Single Root I/O Virtualization interface is an extension to the PCI Express specification. SRIOV defines a method to share a physical function of the I/O port of the I/O device amongst many virtual functions without software emulation. Basically, SRIOV allows for the partitioning of a PCI function into many virtual interfaces for the purpose of sharing a PCIe device's resources in a virtual environment. SRIOV enables network traffic to bypass the software emulation layer, in other words, the hypervisor, and travel directly between the virtual machine and the network interface card. This effectively takes away the I/O overhead incurred by the hypervisor emulation layer by connecting a virtual machine directly to the physical NIC. SRIOV is a standard developed by the PCI SIG working group. The network interface card and your server must support SRIOV, although most do by now. SRIOV is useful only when you need bare metal-like performance for your virtual machine. That is, when you don't want your VM, running in a child partition, to incur the overhead processing of sending all of your I/O through the hypervisor, running in the parent partition. The caveat for SRIOV is that it bypasses the hypervisor or Hyper-V virtual switch. That said, you essentially lose a lot of resource pooling capabilities and other features such as quality of service, sharing of resources amongst a pool of VMs, applying security policies, and using network virtualization. There are some use cases where SRIOV makes sense, for example, running a SQL server, financial applications, video streaming, and virtual desktop infrastructure. Without SRIOV, all network traffic must go through and be processed by the hypervisor and internal virtual switch. This is okay when you are building large general-purpose flexible clouds that use a common resource pool of compute, storage, and networking. This is also useful when you want to apply QoS policies, security policies, or use network virtualization. With SRIOV, all VM network traffic goes directly through the physical network adapter via the virtual function interface. This can lower CPU utilization on the Hyper-V host and increase network throughput significantly. SRIOV allows this by carving up the physical device or physical function into several of the same virtual devices or virtual functions. The physical function is used to configure and manage the SRIOV functionality. The virtual function contains the necessary resources to move data with a smaller set of configuration resources. The virtual function allows direct assignment of a VM to the physical I/O device, providing a native experience and extremely fast I/O. By separating a physical device into PF and VFs, allows a single physical device to appear as multiple separate physical devices when presented to virtual machines. In Hyper-V Manager, SRIOV is a checkbox when you create a new external virtual switch. Note that SRIOV can only be enabled on the creation of a virtual switch, and that switch cannot be converted to an internal or private switch. In System Center Virtual Machine Manager, SRIOV is a checkbox in two places. First, when you create a port profile, and also when you create a logical switch. Note also here that SRIOV can only be enabled on the creation of the port profile and logical switch. It's also important to note that your networking hardware or physical network adapters must support SRIOV in order to take advantage of its benefits. In this video, you learned about SRIOV, what it means, when to use it, and how to turn it on. In the next video, we will learn about VLAN support in Hyper-V. In the previous video, we learned about SRIOV. After watching this video, you will understand what VLANs are, how they work, and when to use them. You will also understand where to enable them in both Hyper-V Manager and System Center Virtual Machine Manager. So far, you've learned about the types of networks you can build in Hyper-V. You've also learned about single root I/O virtualization. Next, we will learn about VLANs in Hyper-V. First, we will learn the basic concept of VLANs, although I'm sure you are already familiar with the technology. Next, we will review how to use VLANs in Hyper-V Manager, and then we will show you how to enable VLANs in System Center Virtual Machine Manager. A virtual LAN, or VLAN, is the logical grouping of one or more physical LANs designed to communicate as if they were on the same physical wire. VLANs are defined by the IEEE 802.1q specification and are an industry standard that is widely adopted. VLANs have been around for a long time now, and to ignore them would be folly. If you've been around long enough to remember how an Ethernet broadcast storm could take down your network by flooding it with traffic, then you remember the wonderful day that VLANs were invented, because they limited broadcast traffic to a single switch port. VLANs simplify network design and deployment because combining hosts and users of those hosts can be done with software, that is VLANs, instead of deploying physical switches and physical wiring everywhere. In addition, VLANs now allow you to transport traffic from multiple different groups of hosts and users across a single wire, reducing cost, allowing you to scale up and out with more flexibility. One caveat with regard to VLANs and Hyper-V: VLAN tags are limited to 4096. Virtual Subnet IDs, or VSIDs, in Hyper-V network virtualization, however, scale up to 16 million. So if you need more than 4096 virtual networks, then you should just use network virtualization and VSIDs. Trunking is also part of the IEEE 802.1q spec, and simply says on any given port, I want to send a whole group of VLANs, not just one, hence the term trunk. The virtual switch provided by Hyper-V is compliant with the official 802.1q standard, which means that it can assign its virtual switch ports to virtual local area networks, or VLANs. Hyper-V will assign 802.1q VLAN tags to outbound packets from those switch ports, and will properly route inbound 802.1q VLAN tagged packets to their proper virtual switch ports. You don't need to do anything in Hyper-V to enable trunking, it's on automatically. However, you will need to configure individual switch ports for the desired VLAN. Do you really need VLANs? I don't know, perhaps not, now with the emergence of virtualized networking. However, since VLANs are so prevalent in data centers around the world, you might need to integrate your Hyper-V infrastructure with them for compatibility with existing systems. Now is a good time to talk about private VLANs and isolation. Private VLANs, or PVLANs, were invented because service providers needed a way to allow multiple customers to run their network on the same physical hardware, but did not want customer A's traffic coming into contact with customer B's traffic for a variety of reasons, mostly surrounding security and privacy. You now recall in a previous video in this section we talked about direct access networks that don't use isolation and network virtualization networks that do use isolation. Here are some bit links that link to information on Microsoft's website. This is really good reading and will help you narrow in on how you should design your own network. Here's a quick nugget of information for you. Isolation, hence network virtualization in Hyper-V, is only necessary in cases where a logical network will be used by multiple customers or tenants. Logical networks created for enterprise or corporate workloads and cloud dedicated to a single customer are all considered single tenant and don't require isolation. So you can use VLANs and/or the direct access network model. If there is no need to isolate network traffic on the logical network, a single VM network configured for no isolation or direct access is all you need. In Hyper-V Manager, VLANs are enabled in two places. First, when you create the virtual switch on the Hyper-V host, and second, when you configure the network adapter in the virtual machine itself. In System Center Virtual Machine Manager, enabling VLANs is a little more complicated because you have multiple IP subnet VLAN pairs in a VM network, and multiple VM networks in a logical network. First, when you create the logical network, you can tell Hyper-V that this logical network will be using either VLANs or PVLANs. Then, when you add a network site, you enter multiple VLAN IP subnets that are part of that site. When you create your logical switch or virtual switch, and you connect your uplink port profile, Here is where you connect the VM network that uses the VLAN, or you create one by clicking on Browse. Now you open up the properties of the Hyper-V host, click on Hardware, then Logical Network Connectivity, and select the VLANs that you want riding through this Hyper-V host adapter. Then you create a logical switch that contains the VLANs you want to go through that switch. Do note that if the virtual switch receives untagged packets, it will distribute them to virtual switch ports that haven't been assigned a VLAN. When those ports send their traffic, it will go out untagged and land on other untagged virtual switch ports and up to the physical wire where the connected physical switch's native VLAN will handle them. The final step is to open up the individual virtual machine properties and assign the network adapter to the appropriate VLAN VM network. In this video, you learned about VLANs in Hyper-V, what it means, when to use them, and how to turn them on. In the next video, we will learn about policies. In the previous video, we learned about VLANs in Hyper-V. After watching this video, you will understand what policies can be applied to Hyper-V networking with regards to security and bandwidth consumption. So far, you've learned about the types of networks you can build in Hyper-V. You also learned about single root I/O virtualization and VLANs. Next, we will cover policies with regards to networking in Hyper-V. There are many policies that can be configured in Hyper-V, but two important types or groups of policies come to mind as being important. Those are policies that have to do with security and bandwidth. First, we will look at security policies as they apply to Hyper-V networking. Next, we will look at policies pertaining to bandwidth consumption. After that, we will cover the concept of a shielded VM and the host guardian service. And finally, we'll look at how to access the Hyper-V PowerShell commandlets and which one to use for setting up a shielded VM. You can see from Microsoft's website that security and bandwidth settings are applied to virtual network adapters through the use of port profiles that can be created once and applied to many VMs. For security, the options are rather obvious when you create a port profile for a virtual network adapter. They are under the Security Settings tab when you create the port profile. Allow MAC spoofing allows the virtual machine to change the source MAC address in outgoing packets. Sometimes load balancers require this. DHCP guard helps protect against malicious virtual machines acting as DHCP servers for man-in-the-middle attacks. Router guard helps protect against advertisement and redirection messages coming from unauthorized virtual machines that are acting as a router. Guest teaming allows you to team virtual network adapters together on the same switch. IEEE priority tagging allows outgoing packets from the virtual network adapter to be tagged with 802.1p priority, which can be used as a QoS mechanism. Allow guest IP addresses allows virtual machines to add and remove IP addresses on the virtual network adapter. This option is mainly used in network virtualization. If we continue to the bandwidth settings of the port profile, you can set bandwidth policies. The bandwidth settings allow you to set minimum bandwidth and maximum bandwidth that is allowed to the virtual network adapter. The settings are expressed as megabits per second or as a weighted value from 0 to 100 in relation to other network adapters. A new feature of Hyper-V 2016 is being able to run shielded virtual machines. A shielded virtual machine is one that runs on a trusted or guarded Hyper-V server and has been authorized to run on that server. This requires the installation of a host guardian server that measures the health of a Hyper-V host and manages and releases keys to the Hyper-V host when powering on virtual machines. The host guardian server runs what is called an attestation service to ensure the trustworthiness of a Hyper-V server, then issues keys to start shielded VMs. The process for running a shielded VM is as follows. A user requests to start a shielded virtual machine. The host guardian service attests to the Hyper-V host validity and then issues keys that allow the shielded VMs to be launched on that Hyper-V host. When it comes to policies, you might think of PowerShell commands. A complete list of Hyper-V PowerShell commandlets can be found at the bit link on the screen. You can turn a VM into a shielded VM by using the Set VM Security Policy commandlet. In this video, you learned about security and bandwidth policies in Hyper-V. In the next video, we will look at load balancing. In the previous video, we learned about policies. After watching this video, you will understand what load balancing is as it pertains to Hyper-V. So far, you've learned about the types of networks you can build with Hyper-V, SRIOV, VLANs, and policies. Next, we will cover load balancing with respect to Hyper-V. The concept of load balancing has been around for a while, however, it becomes new again when it comes to load balancing virtual resources. First, we look at the concept of load balancing Hyper-V hosts themselves. Next, we review how to enable load balancing of virtual machines in VMM. And finally, we will review the network controller, a new feature or new server role for Windows Server 2016. Load balancing can be really useful because a load balancer distributes network traffic across a number of servers and provides high availability by taking unhealthy servers out of rotation. There are several load balancing algorithms in use today, but the simplest and most common is the round-robin method. In load balancing, clients connect to a single IP address or set of IP addresses called a VIP or virtual IP address. This is referred to as the front-end IP address. The load balancer talks to the servers on the back-end IP addresses. In Hyper-V, there are two ways to configure load balancing of virtual machines. The first is for use with direct access networks, and the second is for use with network virtualization networks. For a direct access network, the steps are as follows. Create virtual IP address ranges when you create the IP address pool, and these IP addresses will be used for the front-end VIPs or virtual IP addresses that clients will connect to. Create virtual IP template, which contains the port number of the service to load balance, the protocol, and whether or not you want persistence. Persistence is useful when you have a user connected to a specific server or service that needs to keep track of certain information for that user, such as an e-commerce site. If you were to load balance the user to a different server that did not have all of that information in memory, the user would lose their shopping cart, for example, and would probably navigate to a different site altogether. In the virtual machines that will be load balanced, make sure they have static IP addresses and static MAC addresses. Also in those virtual machines, you need to enable the network load balancing feature. Then you create a service template, and once the virtual IP is known, you create a DNS entry mapping a URL to that VIP. For services running on Linux servers or networks created with Microsoft Network Virtualization, you need to use the hardware load balancing method. The steps are similar, however there's an added step of selecting either a generic type or installing a hardware vendor's load balancer beforehand. A new feature for Windows Server 2016 is the Network Controller. Network Controller is a server role you install from Server Manager. Ideally, Network Controller should be installed in its own separate cluster of servers. Network Controller can manage firewall access control rules for your VMs, deploy and manage network virtualization, including the virtual switch and virtual network adapters, and manage RAS VMs. Most importantly, Network Controller provides management of the software load balancing feature set. The Network Controller runs the Network Controller server role along with the SLB Manager and Health Monitor. The network controller hosts the SLB policies and creates and manages the SLB muxes. The SLB muxes process inbound network traffic and map front-end virtual IP addresses, or VIPs, to back-end dedicated IP addresses, or DIPs. The SLB host agent does need to be installed on every Hyper-V server. In this section, you learned about the different types of networks and switches available in Hyper-V. You also learned that creating and managing these networks in Hyper-V Manager is very different from creating and managing these networks in System Center Virtual Machine Manager. You learned about the difference between a direct access network and a network created to use Windows Network Virtualization. You learned about SRIOV, VLANs, policies for security and bandwidth management, and finally about load balancing of Hyper-V hosts in addition to load balancing of virtual machines. In the next section, we will learn about Hyper-V memory virtualization. Hi, and welcome to Section 4. In this section, we will cover Hyper-V memory virtualization, memory configuration, static versus dynamic memory, memory weighting, startup RAM, memory overhead, and NUMA. We will also look at some basic counters, statistics, and performance monitoring. Now we move on to the first video of this section that deals with Hyper-V memory virtualization. After watching this video, you will understand what memory virtualization is with regards to Hyper-V. Once Hyper-V is installed and virtual machines are talking across the network, you need to understand how the memory, which is a limited resource, is being used by the virtual machines and hypervisors. First, we will explain what memory virtualization is as a concept. Then we will go over the different types of virtual memory and the sophisticated memory management techniques used by some hypervisors, including Hyper-V. Hyper-V memory virtualization allows virtual machines to share a pool of memory by abstracting the physical memory resources and presenting them as virtual resources to virtual machines. In traditional servers, you had only physical memory, which was much simpler, yet also quite limiting. To determine how much RAM you needed, all you needed to do was look at the hardware requirements listed by the software manufacturer and make sure you had enough memory in your system, minus the operating system overhead. Operating systems were quite adept at managing memory. Now we have a hypervisor managing the system memory instead of the operating system. But the operating system, which is now a virtual machine, still needs memory. And there are multiple virtual machines inside of one physical server, so managing memory in a virtualization server just gets more complicated. Many of the hypervisors, including Hyper-V, have become quite sophisticated in the methods they use to manage memory. The key benefit of memory virtualization is that you can now overcommit, or a better term would be oversubscribe, the amount of physical memory you have in the server to your VMs, knowing that not all of it will be used at the same time. Again, this concept applies to virtualization in that you can now make more efficient use of potentially unused resources such as memory. Oversubscription of memory really says that if I have a server with 64 gigabytes of physical memory, I can assign 6 virtual machines, each with 16 gigs of memory, totaling 96 gigs of memory, which is more than the server physically has, knowing that the extra 32 gigabytes of memory will be pulled from other resources that are not using all of their memory. I can even use some parts of disk storage for memory. Memory oversubscription is a great benefit of using virtualization. It means you can overallocate memory to virtual machines than is physically available on the server. This is all well and good if the VMs operate at the low end of their memory allocation, but it gets complicated when VMs start using all or close to all of their allocated memory. This is where memory management comes into play, and there are different memory management techniques used by different hypervisors. Some of them use the same memory management techniques. Hyper-V allows you to configure static or dynamic memory. Static memory is a fixed amount of memory you assign to a virtual machine. The good news is if your VM starts to run out of memory, you can increase this value or even decrease the value while the VM is running. Dynamic memory allows you to configure a range of memory values, including the startup RAM, minimum and maximum RAM, which allows Hyper-V to dynamically manage the memory that the VM uses, leaving unused memory to be available so that Hyper-V can assign this unused memory to other VMs. Memory weighting allows you to assign a higher priority to VMs to obtain free memory from the hypervisor over other VMs. Memory buffer is expressed as a percentage and represents the amount of memory the virtual machine should grab from Hyper-V when it needs more memory. What happens when the entire system managed by the hypervisor starts to run out of memory? Well, the hypervisor starts to implement some memory management techniques in order to reclaim unused memory. Some memory paging techniques allow for VMs to share memory based on some type of algorithm. In some cases, hypervisors will page out to disk or storage. In fact, Hyper-V has a smart paging feature which will use disk space as part of the virtual machine's startup routine. If overall server memory is low and startup RAM cannot be allocated, paging and swapping of memory in VMs is another way that hypervisors reclaim unused memory. Ballooning, which is used by Hyper-V, is a technique the hypervisor uses to artificially inflate the VM's memory allocation requirements, hence the virtual machine balloon. The increase in virtual machine memory required tells the Hyper-V hypervisor to pin some additional memory for the VM to use. To reclaim the memory, the reverse action happens. I mention these memory management techniques because you need to be at least aware of them. However, outside of configuring static versus dynamic memory, you don't need to configure these management techniques because Hyper-V takes care of them for you automatically. In this video, you learned what memory virtualization is and the difference between static and dynamic memory in Hyper-V. You also learned about some memory management techniques used by Hyper-V to reclaim unused memory so that it can assign the memory to other VMs. In the next video, we will view some examples of how and where to configure memory for the virtual machines in Hyper-V. In the previous video, we learned about memory virtualization and memory management techniques. After watching this video, you will understand how to configure memory virtualization in both Hyper-V Manager and System Center Virtual Machine Manager. Now that you understand what memory virtualization is as a concept, we will now look at how to configure it in Hyper-V Manager and also in System Center Virtual Machine Manager. First, we will look at how to create the initial memory configuration in Hyper-V Manager and then in System Center Virtual Machine Manager. After the VMs are up and running, we will show you how and where to change memory configurations. We will first create a couple of VMs, one with a static memory configuration and one with a dynamic memory configuration in Hyper-V Manager. Initial memory configuration happens when you create a new virtual machine. If you want to assign a static amount of memory that gets all of that memory allocated to a virtual machine, not only at startup, but also throughout its life as a running virtual machine, you enter the largest amount of memory the machine will need and do not check the Enable Dynamic Memory checkbox. That's it. That's all there is to it for static memory. If you want to configure dynamic memory, you do need to check the checkbox next to Enable Dynamic Memory, and typically you assign a lower amount of memory for the startup value. The startup RAM value should be the minimum amount of memory the virtual machine will need in order to boot up. In this case, I am saying the VM only needs 2 GB of memory to start and run. Now that the static memory VM is configured, you can see down in the Memory Statistics page at the bottom of Hyper-V Manager, in the Memory tab, that the full 16 GB is assigned to the virtual machine. Compared with the dynamic memory virtual machine, the initial amount assigned is 2 gigabytes, and the actual memory demand is much lower. This virtual machine can expand up to 16 gigabytes of memory if it needs it, but this extra memory can now be used by other VMs in the system, making more efficient use of the memory resources. Hyper-V 2016 allows you to change static and dynamic memory while a VM is running. However, in this tech preview build we have, that doesn't seem to be the case. Therefore, we have shut down the VMs to show you how to change the memory values. Changing static memory is straightforward, and in fact you can convert this VM to use dynamic memory by simply turning on the dynamic memory checkbox for the virtual machine. Changing dynamic memory allows you to fine-tune the startup RAM, minimum and maximum RAM values, and the buffer percentage and priority weighting. In System Center Virtual Machine Manager, configuring memory also happens on initial creation of the virtual machine. Static memory is simple, just assign how much you want to assign to the virtual machine. Assigning dynamic memory in VMM when creating a virtual machine is similar to doing it in Hyper-V Manager. You assign initial startup RAM, minimum and maximum RAM values, and a buffer percentage value. Memory configuration changes can be made for either static or dynamic memory virtual machines after they've been initially created by opening up the property page for the virtual machine, selecting hardware configuration, then memory. Memory weighting is configured in a different place in VMM. If you scroll down to the bottom of the Hardware Properties section, you can find it there. In this video, you learned how to configure virtual machines to use either static or dynamic memory. In the next video, we will talk about memory overhead, smart paging, and NUMA. In the previous video, we learned about memory configuration. After watching this video, you will understand some additional topics related to Hyper-V memory virtualization. Now that you understand what memory virtualization is and how to configure it in Hyper-V, we will look at some other topics relevant to memory virtualization. First, we will look at memory overhead and what that means to Hyper-V. Next, we will look at smart paging, and then we will look at the concept of NUMA and how that affects your virtual machines. One thing you need to be aware of when sizing your servers and virtual machines is that the Hyper-V Hypervisor needs its own chunk of memory for its own operations. The parent partition or Hypervisor kernel needs to be accounted for in memory calculations. Previous guidance said that you would need 2 gigabytes of RAM, but recent guidance for Hyper-V 2016 is you should make sure you have at least 4 gigabytes of RAM for the parent partition or Hyper-V Hypervisor. This assumes that the only host operating system running is Hyper-V. In other words, don't install the full Windows Server modules and run any other applications other than Hyper-V. One thing to take note of is there is no way to configure how much memory to allocate to the parent partition or Hyper-V Hypervisor from within Hyper-V Manager. It seems counterintuitive. Since you don't configure this in Hyper-V Manager, you need to take into account and make sure you have this much RAM left over when allocating virtual machine memory to your virtual machines. For those of you that use System Center Virtual Machine Manager, there is some hope. You can configure how much memory is available to the hypervisor if you navigate to VMs and Services under the All Hosts Hyper-V Host Properties. Click on the Host Reserves section. Smart paging is a feature that is used in dynamic memory. In dynamic memory, you can set the minimum RAM to a lower value than the startup RAM. When the VM is rebooted when problems occur, is because after the reboot, the VM might be using a smaller amount of RAM, and that extra RAM then became available to other VMs, and now it's no longer available to start up that VM. Smart paging uses a portion of disk storage to compensate for that discrepancy in startup RAM. The smart paging file is only used for the boot process on a VM and nothing else. Although you can't configure how much space the smart paging file can use, you can change where to store it in Hyper-V Manager. Non-uniform memory access, or NUMA memory, is memory that sits on or next to the CPU or processor. A CPU or processor can access its own local NUMA memory faster than non-local memory, or memory local to another processor, or memory shared between processors. The last sentence is important because we have multi-socket CPUs in our servers now. So you could potentially have some instructions executing on a CPU on the chip in socket 1 and its CPU memory being accessed on the NUMA in the chip on socket 2. This would be suboptimal, but it is allowed, and you can configure NUMA in two places in Hyper-V Manager. First, in the Hypervisor properties, you can enable NUMA spanning. And then in the virtual machine properties, you can configure specific values. In System Center Virtual Machine Manager, you configure NUMA on the Virtual Machines Properties page. In this video, you learned about memory overhead, smart paging, and NUMA. In the next video, we will talk about virtual memory counters, statistics, and performance monitoring. In the previous video, we learned about memory overhead, smart paging, and NUMA. After watching this video, you will understand how to access some simple counters, statistics, and performance monitors for Hyper-V memory. Now that you understand what memory virtualization is, how to configure it, and some additional considerations with regard to Hyper-V memory, we will now look at some memory counters, statistics, and performance monitors. First, we will look at some quickly accessible and simple memory counters and statistics. Next, we will look at some more advanced statistics, and then we will take a look at some simple performance monitors for memory in Hyper-V. Some basic memory counters are available through the Hyper-V Manager at the bottom under the Memory tab. Static counters are fairly simple. Dynamic counters offer a bit more information. Assigned memory is the amount of memory allocated to the virtual machine at this time. Memory demand is the amount of memory required at this time to fulfill the requirements of the applications running in the virtual machine. Memory status can be OK, low, or warning. A status of OK means the Hyper-V has enough memory to provide a full memory buffer to the selected virtual machine. A status of low means that Hyper-V doesn't have enough memory to satisfy the memory buffer in full to the virtual machine. Warning means that Hyper-V is reporting that it does not have any available memory to dedicate to the memory buffer, and Hyper-V will likely start using memory reclamation techniques such as smart paging or waiting. In effect, Hyper-V is saying you don't have enough memory in the system, so you either have to add more memory or migrate VMs to other Hyper-V servers. To view performance monitors on the Hyper-V server, you will need to launch computer management from a server that is running a GUI. For example, the Hyper-V Manager or System Center Virtual Machine Manager. Then navigate to the Performance Monitor and make sure you browse to or enter the Hyper-V server hostname so you can view performance counters for that specific Hyper-V server. Click on the green plus sign and you will see there are some built-in monitors for memory monitoring, such as Hyper-V Dynamic Memory Balancer, which shows how much memory is available and how the pressure is building in the Hyper-V server. If pressure is below 100, you're good. If pressure exceeds 100, you will have performance degradation and need to look at how much memory you've configured in your system. The other performance monitor is Hyper-V Dynamic Memory VM, which allows you to look at per VM memory statistics. Average pressure is the same type of pressure as the Hypervisor system-wide, and it should be below 100 in a healthy VM and Hyper-V server. The current pressure is available memory for a virtual machine. Guest visible physical memory is the amount of memory that the virtual machine has visibility to. Maximum pressure is maximum memory available to the virtual machine. Minimum pressure is the minimum memory available to the virtual machine. Physical memory is the current amount of memory in the virtual machine. And the smart paging working set is the size of the smart paging working set for a virtual machine. If you switch the view from line to report, you can get a slightly more readable view of the performance statistics. In this section, we learned about memory virtualization. We learned how to configure virtual memory for virtual machines using both static and dynamic memory settings. We also learned about hypervisor memory overhead, smart paging, and NUMA. We also looked at some basic memory counters, statistics, and performance monitors. In the next section, we will learn about CPU virtualization. Hi, and welcome to Section 5 of Learning Windows Server Hyper-V 2016. In this section, we will cover Hyper-V CPU virtualization, configuration, enlightened I/O, CPU affinity, and finally some CPU counters, statistics, and performance monitoring techniques. Now we move on to the first video of this section that deals with Hyper-V CPU virtualization. After watching this video, you will understand what CPU virtualization is with regards to Hyper-V. Once Hyper-V is installed, the virtual machines need to run their processes. The hypervisor and the virtual machines all need CPU resources, but they can't all use the same CPUs at the same time, or can they? Just like memory, CPUs are a limited resource. First, we will explain what CPU virtualization is, and then we will go over some concepts and terms related to CPU virtualization. CPU virtualization abstracts the physical CPU that allows multiple virtual machines to share a common set of processor resources. A virtual CPU, or vCPU, is a virtual processor instance running in a physical CPU that is assigned to a virtual machine. If the physical virtualization host has multiple CPU cores at its disposal, then a CPU scheduler assigns execution contexts, and the vCPU essentially becomes a series of time slots on logical processors that are running on the physical processor. In traditional servers, you had physical CPUs, which was much simpler, yet also quite limiting. If you go back far enough, there was a time when there would be only one CPU in the computer, and we sure have come a long way. We now have more than one processor chip inside of servers, and each of those chips or sockets on the motherboard contain multiple cores that act as CPUs. Now, with hyperthreading and thread scheduling, those can be divided up even further to help spread resources out to many more virtual machines. Every virtual machine gets assigned to it at least one virtual CPU in Hyper-V, but you can assign more if needed. The key benefit of CPU virtualization is that you can now oversubscribe the number of physical CPUs you have in the server to your VMs, knowing that not all of the idle processor resources will be used at the same time. In other words, you can in fact assign more virtual CPUs than you have physical CPU resources in the server. Again, this concept applies to virtualization very neatly as a concept because you can now make more efficient use of potentially unused resources, such as idle CPU time. Oversubscription of CPUs really says that if I have a server with 2 CPUs in 2 sockets, each with 4 cores, then I have a total of 8 physical cores. In virtualization and with hyperthreading enabled, I can slice and dice these into many more than 16 virtual CPUs. There are some terms we need to review and understand. The Hyper-V hypervisor takes the physical processors or CPUs or cores, whatever you choose to call them, and abstracts these into virtual CPUs or vCPUs. Virtual machines are allocated at least one vCPU each. If the physical host has multiple CPU cores at its disposal, then the CPU scheduler assigns execution contexts, and the vCPU essentially becomes a series of time slots on logical processors. SMP stands for symmetric multiprocessing. SMP allows threads to be split across multiple physical or logical cores to improve performance of parallel virtualized tasks. vCPUs permit multitasking to be performed sequentially in a multi-core environment. Hyperthreading is a technology used by some Intel microprocessors that allows a single microprocessor to act like two separate processors to the operating system and the application programs that use it. So essentially, if you enable hyperthreading, you can turn an 8-core CPU server into a 16-core CPU server. A hypervisor must schedule time on a vCPU for the VM. As long as all of the VM's time is slated for the same vCPU, there is no real conflict. But when a VM uses multiple vCPUs that cross 2 or more cores, the hypervisor must now schedule time on 2 or more physical resources. This means that the hypervisor and the VM it's scheduling must wait for time on different physical processor cores. For common single-threaded workloads that are not explicitly designed for SMP behavior, the hypervisor can wind up wasting a lot of time holding up VM execution, waiting for time on multiple vCPUs. This will actually slow down the VM's performance. In these situations, reducing the processing to just one vCPU can actually improve the workload's performance. Each virtual machine is running programs, and each program is a process that contains many threads. The Hyper-V hypervisor schedules threads to be executed on the virtual CPUs or virtual cores in the server. So how many virtual machines can you fit on a core, or how many vCPUs should you assign to a virtual machine? It depends on the workload running on the virtual machines. There are good sizing guides out on the internet, but a typical 3.0 GHz quad-core, 2 CPU server typically can handle anywhere from 30 to 80 virtual machines. One final note on a feature called CPU compatibility. Processor compatibility applies to any virtual machine that will be involved in a mobility scenario such as live migration. You need to check the compatibility box if you plan to live migrate the VM to a server that has different CPUs than the one it is currently running on. In this video, you learned what CPU virtualization, along with some important terms and concepts, are related to CPU virtualization. In the next video, we will view some examples of how and where to configure virtual CPUs for the virtual machines. In the previous video, we learned about Hyper-V CPU virtualization. After watching this video, you will understand how to configure CPU virtualization for Hyper-V virtual machines. Now that you understand what CPU virtualization is all about, we need to take a look at where to configure it. More specifically, how to assign virtual CPUs to your virtual machines. First, we will look at where and how to configure vCPUs in Hyper-V Manager. Then we will go over some additional settings with regards to CPU scheduling and control. Last, we will look at how to configure vCPUs in System Center Virtual Machine Manager. In Hyper-V Manager, when you create a virtual machine for the first time using the wizard, you will notice that there is no place to configure the number of processors or virtual CPUs. However, once the VM is created, you can go into the VM settings, and there you can configure virtual CPU settings. The VM is automatically assigned one vCPU, and you can increase this value. This is the value that the virtual machine sees and can use, and the maximum number is the number of cores on the physical server. The virtual machine reserve is the percentage of assigned vCPUs that Hyper-V will reserve and keep as available for this VM. Percent of total system resources is the assigned vCPUs divided by total system CPUs multiplied by the reserve percentage. So for example, if we assigned 12 vCPUs in a 24 CPU system and reserved 10% of that, the percent of total system resources would be 5%. The virtual machine limit determines what percentage of each virtual CPU the VM can consume. Percent of total system resources is a calculated percentage taking assigned vCPUs divided by total system CPU times limit percent. So for example, if we have assigned 12 vCPUs in a 24 CPU system and limited the VM to use only 50% of each vCPU, the percentage of total system resources would be 25%. And that actually seems a little high, so we might want to reduce the virtual machine limit percentage. Relative weight is a whole integer value between 0 and 10,000, and it is a priority queuing system. You can set a higher weight or priority for some VMs and lower weight for other VMs. The higher the value, the more priority the VM gets when it is scheduled CPU resources by the CPU scheduler. In System Center Virtual Machine Manager, you can assign the number of vCPUs to a virtual machine in the VM creation wizard. However, to change the resource control values, you need to navigate to the VM's properties. Select Hardware Configuration and click on CPU Priority down at the bottom. Here you can see the same values that you see in Hyper-V Manager, but under different names. The weight or priority appears first. Reserve CPU cycle tells Hyper-V how much of the assigned vCPUs to keep in reserve. Limit CPU cycles tells Hyper-V how much of assigned CPUs the VM can consume. The calculation for percentage of total system resources is the same as it is in Hyper-V Manager. The same is true for any VM templates that you create in VMM. You will be able to create the VM using an existing VM, and it will pull forward the settings from that VM into the template. However, you can go back into the properties for the template later and adjust the values. In this video, you learned where and how to configure virtual CPUs for virtual machines. In the next video, we will learn about Enlightened I/O. In the previous video, we learned about virtual CPU configuration. After watching this video, you will understand what Enlightened I/O is with regards to Hyper-V. Now your virtual machines are configured with multiple virtual CPUs and resource control settings are tuned to perfection. Let's take a look at an important concept called Enlightened I/O. First, we explain what Enlightened I/O is, as it is related to Hyper-V. Then we explain what virtualization is without Enlightened I/O. As you know by now, there is some overhead associated with running virtual machines on top of a hypervisor, which runs on top of the physical server. Translation between the parent partition, or Hyper-V, and the child partitions, or virtual machines, needs to somehow occur to allow VMs to interact with the underlying physical server components. The goal of many hypervisors is to reduce the overhead so that the virtual machines look and feel like they are running on bare metal. Hyper-V provides this performance tuning through what is called Enlightened I/O, and Enlightened I/O can only happen if the virtual server client code is installed in the virtual machine. The virtual server client code is also known as Enlightened I/O, and it happens to get installed with integration services. As you know by now, integration services is automatically installed with Windows virtual machines, but you do need to install them separately for Linux-based virtual machines. Enlightened I/O gives a virtual machine direct access to the virtual machine bus, or VM bus. Enlightened I/O is a specialized virtualization-aware implementation of high-level communication protocols that utilize the VM bus directly, bypassing any device emulation layer. The result is better performance. Enlightened I/O applies to just about every hardware subsystem on the server: memory, storage, networking, CPU. So why talk about it here in the CPU virtualization section? Because in order for Hyper-V to effectively use Enlightened I/O, it requires a CPU or processor vendor that supports and includes hardware-assisted virtualization. Such processors are available with Intel VT and AMD V virtualization technology. Intel virtualization technology, or Intel VT, represents a portfolio of technologies that make virtualization possible by eliminating virtualization overhead. With Intel virtualization technology, the CPU is instructed to act as if it had several CPUs to farm out to several operating systems, running at the same time on the same machine. The Intel VTX extensions are probably the best recognized extensions that add migration, priority, and memory handling capabilities to a wide range of Intel processors. The Intel VT-D extensions add virtualization support to Intel chipsets that can assign specific I/O devices to specific virtual machines. The VT-C extensions bring better virtualization support to I/O devices such as network switches. Without Enlightened I/O, a virtual machine would have to be completely emulated. That is, all of the underlying hardware would have to be simulated enough for a virtual machine operating system to run unmodified without any special drivers. Everything from CPU instructions, I/O processes, memory constructs, that is, everything must be completely emulated in the software by the hypervisor before any of that information can be passed between the hypervisor and the underlying hardware. This is essentially the first form of virtualization that existed for virtual machines way back in the day. We've come a long way, and hypervisors and hardware vendors have become more adept at virtualization through the use of drivers such as Hyper-V Enlightened I/O and hardware improvements such as Intel and AMD virtualization technology. The good news is Enlightened I/O through integration services is automatically turned on when you install Windows operating systems into VMs. You can manually enable Enlightened I/O by installing integration services into Linux VMs. In this video, you learned about Enlightened I/O. In the next video, we will learn about CPU affinity. In the previous video, we learned about Enlightened I/O. After watching this video, you will understand what CPU affinity is with regards to Hyper-V. Now that your virtual machines are configured with multiple virtual CPUs and resource control settings are tuned to perfection, and Enlightened I/O is kicking in for blazing fast performance, let's talk about CPU affinity. First, we'll explain what CPU affinity is, then we show you how to configure it in Hyper-V Manager and System Center Virtual Machine Manager. Last, we talk about when you should or should not use CPU affinity. CPU affinity, or processor affinity, binds a process or thread to a specific CPU or range of CPUs, so that the process or thread executes only on the designated CPU or CPUs. CPU affinity is also known as CPU pinning, as you effectively pin the processes and threads to a specific CPU or set of CPUs. To configure or set or pin processing to specific CPUs in Hyper-V Manager, you open up the VM settings, select Processor, and then set the Virtual Machine Reserve and Virtual Machine Limit to 100%. This is the setting that says wherever the virtual machine is running, it will get the number of virtual processors, whatever that value is set to, and it will get to use them completely. Keep in mind, this does not mean that the VM will be pinned to a specific physical CPU every time it runs, but it will be pinned to a CPU when it does run. One thing to keep in mind is that if you are going to pin virtual machines to CPUs, make sure you don't allow NUMA spanning, that is, allowing processes to use NUMA memory on the other CPU socket. This will slow down performance. You want to keep the CPU and NUMA memory contained into the same NUMA node, if you will. In Hyper-V Manager, NUMA nodes are configured under the Settings in the NUMA section of the Processors field. In System Center Virtual Machine Manager, NUMA nodes can actually be configured under a section of hardware configuration called Virtual NUMA. Here, you can actually configure the number of CPUs and the amount of NUMA memory for each NUMA node, and the number of NUMA nodes per physical CPU socket. Is it a good idea to use CPU affinity or CPU pinning along with NUMA nodes? That's a subject for debate. While pinning a VM's processes to a specific CPU and NUMA node, you can increase its performance. However, you can't really pin all of your VMs to CPUs and NUMA nodes because eventually you will run out of CPUs and NUMA nodes, because CPUs are a limited resource, even with hyperthreading enabled. Also, when you enable CPU pinning, you basically interrupt the job of the kernel CPU scheduler. And it can't really work to optimize all the processes because your pinned VM keeps butting to the front of the line. There are some rare instances where a VM needs to have the entire CPU, and if you run across that virtual machine, then you know how to enable it now. In the meantime, just let your Hyper-V CPU scheduler do its job and try running without VMs pinned to CPUs. In this video, you learned about CPU affinity. In the next video, we will learn about virtual CPU performance monitoring. In the previous video, we learned about CPU affinity or pinning. After watching this video, you will understand how to check CPU counters, statistics, and performance monitors. Now that you know everything there is to know about CPU virtualization, how do you know if your CPUs are even performing efficiently? In this video, we will look at CPU performance monitoring. First, we look at some basic CPU counters and statistics in Hyper-V Manager. Then we look at CPU counters and statistics in System Center Virtual Machine Manager. And then we will look at some statistics in Computer Management Performance Monitoring. In Hyper-V Manager, you can see CPU utilization of each virtual machine in the center frame of the virtual machine's information window. To view CPU utilization in System Center Virtual Machine Manager, you need to right-click on the column headings and put a check mark next to CPU average and CPU count. Then those counters or statistics will show up next to each virtual machine. To view performance monitors on the Hyper-V server, you will need to launch computer management from a server with a GUI, such as Hyper-V Manager or Virtual Machine Manager. Then navigate to the performance monitor and make sure you browse to or enter the Hyper-V server host name so you can view performance counters for that specific Hyper-V server. Click on the green plus sign and you will see there are some built-in monitors for CPU monitoring. This is one of the better ways or more accurate ways to view processor utilization by virtual machines. The Hyper-V Hypervisor Virtual Processor Counter for percentage of guest runtime shows the percentage of time spent by the virtual processor running the virtual machine code. This is a good counter to use to determine which virtual processors are consuming CPU cycles for virtual machines. The Hyper-V Hypervisor Logical Processor Counter for percentage of total runtime shows the percentage of time spent by the logical processor running both hypervisor code and virtual machine code together. If total runtime is below 60%, virtual machine and host processor utilization is healthy. If total runtime is between 60 and 90%, virtual machine and host processor utilization is borderline high and caution should be observed. If total runtime is between 90 and 100%, virtual machine and host processor utilization is high and performance will be adversely affected. Another trick is to compare percentage of total runtime for the Hyper-V Hypervisor logical processor versus the Hyper-V Hypervisor virtual processor. If the virtual processor runtime is high and the logical processor runtime is low, it means there are available logical processors to allocate to virtual machines. So you can increase the number of vCPUs or virtual processors allocated to a virtual machine to improve performance. Or you can add more virtual machines as there is excess processor capacity that can be further utilized. If both virtual and logical processor runtime is high, then your virtual machines are pushing the limits of capacity and you might see performance degradation. In this section, you learned about CPU virtualization and how CPUs are treated differently in virtualization. You learned how to configure CPU virtualization, or in other words, how to assign virtual CPUs to virtual machines in both Hyper-V Manager and also in System Center Virtual Machine Manager. You learned about Enlightened I/O and that it is automatically enabled when you install a Windows operating system into a virtual machine via V integration services. You learned about CPU affinity or CPU pinning and whether or not it is a good idea to use it. Finally, you learned how to use CPU counters, statistics, and performance monitors for both the hypervisor and individual virtual machines. In the next section, we will learn about storage virtualization as it applies to Hyper-V. Hi, and welcome to Section 6 of Learning Windows Server Hyper-V 2016. In this section, we will cover Hyper-V storage virtualization, configuration, IOPS and storage quality of service, multipath I/O, shared versus dedicated storage, failover clustering, resilient file system, live migration, and storage spaces. Now we move on to the first video of this section that deals with Hyper-V storage virtualization. After watching this video, you will understand what storage virtualization is with regards to Hyper-V. Once Hyper-V is installed, most likely to a local disk drive in the server, the virtual machines and their data need to be stored somewhere. First, and most important, we discuss the virtual hard disk that Hyper-V uses for its virtual machines. Then we explain what storage virtualization is and some concepts and terms related to it. After that, we go into some specific concepts of storage virtualization that you are undoubtedly going to encounter. Storage virtualization is the pooling of physical storage from multiple networked or local storage devices into what appears to be a single storage device that is managed from a central console. In traditional servers, you only had physical storage, which was much simpler, yet also quite limiting. To determine how much disk space you needed, all you had to do was look at the hardware requirements listed by the software manufacturer and make sure you had enough disk space in your system, minus the operating system overhead. Operating systems were quite adept at managing storage when it was locally attached and inside of the same server. Now we have a hypervisor managing the system storage instead of the operating system. But the operating system, which is now a virtual machine, still needs disk storage. And there are multiple virtual machines inside of one physical server, so managing storage in a virtualization server just got more complicated. Many of the hypervisors, including Hyper-V, have become quite sophisticated in the methods they use to manage storage. The key benefit of storage virtualization is that you can now pool many disks and make them available to virtual machines through different technologies, including networked storage devices such as network-attached storage and storage area networks. With storage available as local disks for the hypervisor and networked disks for virtual machine storage, storage pooling and storage virtualization becomes an almost limitless and powerful tool. Before we get too much further into this, we need to discuss the Hyper-V virtual disk format. Hyper-V usually gets installed on the local server, direct attached internal disks. The virtual machines, however, get installed where? They get installed into virtual hard disks. Virtual hard disks don't exist by default, they need to be created, and with the new VHDX format, they can now be up to 64 terabytes in size. Hyper-V now uses the extended virtual hard disk format to store VMs in. The VHDX files are typically located on a SAN device of some sort. It is possible to create VHDX files on locally attached storage, but this should only be done in lab trials and proof of concepts. Now let's spend some time going over some storage concepts. File-based storage is the simplest form of storage and dates back to the early days of storing files on computer disks. File storage, or files, are accessed using common file-level protocols such as SMB or CIFS in the case of Windows, or NFS in the case of Linux. File storage is commonly associated with network-attached storage, or NAS devices. This is different than block storage, where you would create a volume, deploy an operating system on top of it, which would attach to the created volume and handle the files and folders on the device. Block-level storage presents itself to servers using industry-standard fiber channel and iSCSI connectivity mechanisms. In block-level storage, raw storage volumes are created, then the server-based operating system connects to these volumes and uses them as individual hard drives. Block storage devices are commonly associated with storage area network, or SAN devices. Direct attached storage refers to a computer storage system that is directly attached to your server, or PC, instead of being attached directly to a network. Direct attached storage is not limited only to internal storage. It can also utilize an external disk enclosure that contains hard disk drives, including just a bunch of disks, or JBOD enclosures, and enclosures that are part of a redundant array of independent disks, or RAID. JBOD is an abbreviation for just a bunch of disks. In other words, the disks are presented to a computer as if they were directly attached internal disks, and they are used to increase the direct attached storage capacity of the file servers. JBODs are usually relatively simple external enclosures connected to one or more servers through SAS or eSATA connections. You can use JBODs with the storage spaces technology to combine all of your physical disks into a storage pool, and then create one or more virtual disks called storage spaces out of the free space in the pool. Network-attached storage devices connect storage to a network where they are accessed through file shares. Unlike direct attached storage, they are not directly attached to the computer. However, they are attached to the network. A SAN does not provide file abstraction, only block-level operations. The most common SAN protocols used are iSCSI, fiber channel, and fiber channel over Ethernet. A SAN consists of a storage device, the interconnecting network infrastructure, such as switches, and servers that are connected to this network. SAN devices provide continuous and fast access to large amounts of data. The communication and data transfer mechanism for a given deployment is commonly known as a storage fabric. A SAN uses a separate network and is generally not accessible by other devices through the local area network. The Internet SCSI protocol encapsulates SCSI commands into TCP packets, then transmits them over the Ethernet network to storage devices. The iSCSI protocol uses an existing TCP/IP infrastructure and resolves traditional SCSI distance limitations. The iSCSI protocol enables the disk drives in your SAN to be presented over an Ethernet network to server-based applications as though the disks were local to your physical server hardware. Fiber channel is a high-speed network technology that is used to connect computer data storage. It is the most common connection technology for SANs, although iSCSI is increasingly popular. Typically, a SAN utilizes fiber channel, which is a transport protocol that transports SCSI commands over fiber channel networks. So, how does all this fit together? Physical disks are combined into a storage area network device, or SAN, or even a network-attached storage device. You created a volume from that combined storage, and when you create your virtual hard disk, or VHDX file, it gets stored on that volume. In this video, you learned what storage virtualization is and all of the different terms and concepts surrounding it. In the next video, we will review some samples or examples of how to and where to configure storage for the virtual machines. In the previous video, we learned about storage virtualization in Hyper-V. After watching this video, you will understand how to configure storage virtualization in Hyper-V Manager as well as System Center Virtual Machine Manager. There are a couple ways to create a virtual hard disk in Hyper-V Manager. When you use the wizard to create a new virtual machine, it will ask you where you want to store the virtual hard disk and how large you want it to be. If you created the virtual hard disk ahead of time, you can use that, or you can choose to create the virtual hard disk later on. When you create a virtual hard disk in Hyper-V Manager, it automatically creates a dynamically expanding disk. There is no other option. Speaking of creating a virtual hard disk ahead of time, you can do this in Hyper-V Manager by selecting New, Hard Disk from the right side navigation frame. This opens up the New Virtual Hard Disk wizard. Where this would become useful is if you wanted to add another disk drive to your virtual machine. You could use the wizard to create the virtual disk and then go into the hardware properties of the virtual machine and assign it to the VM there. When creating a virtual machine in System Center Virtual Machine Manager, you do have more options. Right away, the wizard asks you if you want to create a new blank virtual disk or use one from an existing VM, a VM template, or a virtual disk created beforehand. When configuring the hardware section, you can change the virtual SCSI channel and select whether or not you want a dynamic or fixed allocated disk. A quick note on fixed versus dynamic virtual disks. One thing to keep in mind is a virtual disk is really just a very big file. Using a dynamic virtual disk, also known as thin provisioning, lays down some header and footer information and slowly expands the disk as information is written to it. This is nice because you don't end up using up all of your disk space, so you could potentially oversubscribe storage space to virtual machines. This could help keep virtual machines lightweight and small, especially when doing backups. The downside is that data storage could potentially get fragmented as Hyper-V looks for new free space to expand the virtual disk storage to. Fixed virtual disks, on the other hand, are just that, a fixed amount of storage space. These are purportedly faster than dynamic virtual disks, but make your VM storage seem large and bloated. There is a pass-through option which allows you to pass through the VM's data directly to a hard disk on the host or SAN. This option is provided for high-performance virtual machines. Using thin-provisioned, dynamically expanding virtual disks is a benefit of virtualization and is probably the best option, unless you have a VM that requires a fixed disk size. If you click on the virtual SCSI adapter, you can also change the SCSI interface as well. Finally, how do you know how much disk space you have available to assign to virtual hard disks? One way is to connect to the Hyper-V server using computer management from the Hyper-V Manager or VMM server, or one that has a Windows GUI installed. Navigate to Disk Management and you should see unallocated space. In this video, you learned how to configure storage virtualization and create virtual hard disks for VMs using Hyper-V Manager and System Center Virtual Machine Manager. In the next video, we will learn about IOPS. In the previous video, we learned how to configure storage virtualization in Hyper-V Manager and Virtual Machine Manager. After watching this video, you will understand what IOPS is and how to configure it in Hyper-V Manager as well as System Center Virtual Machine Manager. Now that you have a bunch of virtual machines up and running in Hyper-V, you may notice that some aren't performing well, and you've recently run across this controversial subject of IOPS. First, we will take a moment to discuss what IOPS is and whether or not it's important. Then we will show you how to configure IOPS in Hyper-V Manager, and finally we will show you how to configure IOPS in System Center Virtual Machine Manager. IOPS stands for Input-Output Operations per Second. It is commonly misused and misunderstood, and is a performance measurement used to characterize computer storage devices like hard disk drives, solid-state drives, and storage area networks. IOPS alone might not mean much, but it has meaning when considered together with latency, type of I/O, read versus write, size of data, adjacency of data. IOPS can also be dependent on host CPU, memory, and network, not only in the Hyper-V server, but also in the storage array itself. In addition, tribal knowledge says that latency plays a big part, so you could have a system that is capable of high number of IOPS, but performance may be bad because of high latency. There are many factors that play into IOPS, such as the speed of physical disk drives, number of disk drives, interface throughput, type of storage, RAID configuration, size of data being read or written, and finally the read-write blend. Some read-write blends are 50-50, others are 70% write and 30% read. Storage vendors themselves will claim massive amounts of IOPS capability, and you should look at them with a discerning eye because anyone can claim high IOPS. There are even some software vendors that will be able to increase hardware-based IOPS through the use of deduplication and compression technologies. Also keep in mind that not all VMs and applications are I/O intensive. One application that is I/O intensive that comes to mind would be a SQL server. Considering IOPS and quality of service for virtual hard disks will bring up the question of SATA versus SAS versus SSD. SATA drives, or Serial Advanced Technology Attached Drives, are the least expensive, yet are the slowest. Serial Attached SCSI are faster and a little more expensive. Solid-state drives are very fast and very expensive. Most of the time, you can get away with using basic SATA drives for your applications. IOPS are applied and managed through a feature called Storage Quality of Service. IOPS are applied to the virtual hard disk. This feature allows you to reserve storage IOPS for a virtual hard disk by specifying a minimum number of IOPS and a maximum number of IOPS. Every 8K bytes of data counts as an I/O operation. What should you set your IOPS values to? It's hard to say because different virtualization environments perform differently. There are a lot of factors that influence IOPS. The best way to measure IOPS that I can think of is to do the following. Run your virtual machines without IOPS and see how they perform. Measure IOPS for each virtual machine and taking note of the maximum values. Then set IOPS on the virtual machine's .vhdx files accordingly. In some cases, you may not need to fiddle with IOPS settings, which is actually better than imposing limits on your VMs. IOPS per VM can actually be found using PowerShell commands. First, you enable resource metering for your virtual machines, and then you run the following PowerShell commands to view the read and write percentage of total IOPS. A good generic formula for calculating IOPS is the I/O profile that equals total unit workload IOPS times percentage of reads plus the total unit workload of IOPS times the percentage of writes times the RAID penalty. In Hyper-V Manager, IOPS values can be set in the VM settings under the hard disk drive quality of service features. In System Center Virtual Machine Manager, IOPS can be set in a couple of places. First of all, in the Hardware Configuration section of the Virtual Machine Properties, and IOPS can also be set on the Hyper-V host itself. You can create a QoS storage policy that can be applied to a storage array, or you can create a storage policy that can be applied to individual virtual disks. In this video, you learned about IOPS. In the next video, we will learn about multipath I/O. In the previous video, we learned about IOPS. After watching this video, you will understand what multipath I/O is and how to configure it for Hyper-V. So your Hyper-V hosts are up and humming and you have virtual machines running. Now you start to look into the different facets of storage. One of those facets or features is multipath I/O. First, we will take a moment to discuss what multipath I/O is. Then we will show you how to configure multipath I/O for Hyper-V. Multipath I/O is a Microsoft framework designed to mitigate host bus adapter failure by providing an alternate data path between storage devices and the server. Data is mission critical, and now that storage has been decoupled from the server in a virtualization environment, having one adapter and one path to the data is just not an option. If that host bus adapter goes up in flames, you lose your data connection, and every second you're down counts against you. This is just too risky. Multipath I/O allows Windows and/or Hyper-V to manage up to 32 paths between storage devices. MPIO provides the logical facility for routing I/O over redundant hardware paths connecting server to storage. These redundant hardware paths are made up of components such as cabling, host bus adapters, switches, storage controllers, and possibly even power. MPIO solutions logically manage these redundant connections so that I/O requests can be rerouted if a component along one of the paths fails. As more and more data is consolidated on storage area networks, the potential loss of access to storage resources is unacceptable. To mitigate the risk, high availability solutions such as multipath I/O have now become a requirement. Although multipath I/O and failover clustering result in high availability, they are not the same. Failover clustering provides high application availability in case of server failure, while MPIO provides high availability of connectivity to storage. They can be used and should be used together. For multipath I/O to work, there are two components required. There is a device-specific module, or DSM, that is provided by the storage array manufacturer. It can be used on Fiber Channel, iSCSI, or SAS shared storage types. Microsoft does not provide a generic DSM, by the way. The second piece is the multipath I/O software in the Windows Hyper-V server. If you want to use this, you will need to install it separately. Multipath I/O works by logically grouping together different storage devices, but it can only do so if each device or logical unit number has a unique hardware identifier, which is usually assigned by the device manufacturer. When the multipath I/O driver, in combination with the DSM, detects a failure, failover and recovery is extremely fast and transparent. Any data that remains outstanding is sent over the redundant path so the data remains intact and available. Multipath I/O is a feature that must be added separately to Hyper-V. To do it through a GUI, open Server Manager, connect to the Hyper-V server, add roles and features, and check the box next to MPIO, then finish the installation. You will need to reboot the server for multipath I/O to take effect. In this video, you learned about multipath I/O. In the next video, we will learn about shared versus dedicated storage. In the previous video, we learned about multipath I/O. After watching this video, you will understand the difference between shared and dedicated storage. So you're almost finished with your lab or proof of concept with a couple of Hyper-V servers, and you're thinking about production, or even just thinking about redundant storage. Investing in a storage array has benefits, but will it be dedicated or shared among Hyper-V hosts? First, we will take a minute to discuss shared versus dedicated storage. Then we will show you why you would need either of them. Dedicated storage refers to storage that is dedicated to a single Hyper-V host. Dedicated storage can be local storage, direct attached through a host bus adapter, or even a network storage device such as a NAS or a SAN. Dedicated storage is useful for labs, proof of concepts, and situations where you want to keep the costs down. Shared storage refers to a storage device that can be shared or accessible by multiple Hyper-V hosts. If you are already using a network storage device such as a SAN with iSCSI or FCOE, then you are already on your way. The reason for shared storage is simple. An unclustered Hyper-V server is a major point of failure. Clustering Hyper-V hosts together is one way to eliminate the single point of failure. However, the piece that goes along with Hyper-V clustering is storage that can be shared by clustered Hyper-V servers. In case one Hyper-V host goes down, another Hyper-V host can pick up the virtual machines and keep running them from the same virtual hard disks. Shared storage is great for production environments or where high availability is utterly important. The caveat with shared storage, it is also quite expensive. In this video, you learned about shared versus dedicated storage. In the next video, we will learn about failover clustering. In the previous video, we learned about shared versus dedicated storage. After watching this video, you will understand what Hyper-V failover clustering and clustered shared volumes is. So you're thinking that you want a total high availability Hyper-V system. The discussion wouldn't be possible unless we talk about failover clustering and clustered shared volumes. First, we take a minute to discuss what failover clustering is, and then we will talk about clustered shared volumes, and then we will show you some examples of how to configure both of them. So why wait until now to talk about failover clustering and clustered shared volumes? Well, because getting them up and running is a big undertaking and can be quite involved in terms of time and money. You need at least 2 Hyper-V servers that will be used to form a cluster of Hyper-V servers. The cluster of servers work together to provide high availability, and that if one of the servers fails, the other servers pick right up where the failed one left off, so there is no disruption to the end user's applications. A clustered shared volume is a set of shared disks, most likely in a SAN connected through iSCSI, containing an NTFS or REFS volume that is accessible by all nodes in the Windows Server failover cluster. The benefit here, again, is if one of the Hyper-V servers in the cluster fails, the other server in the cluster can access the same storage and continue running the failed server's applications and access its data seamlessly. By the way, Tribal Knowledge says always use NTFS as the file system in clustered shared volumes for performance reasons. The steps to creating a failover cluster with clustered shared volumes is pretty straightforward. Doing these tasks is what takes a long time and is painstaking if you don't follow directions exactly. First, you need to enable failover clustering and multipath I/O on all nodes that you want to participate in the cluster, even if you have a separate node you use just for management with a GUI. Then, you need to create your iSCSI SAN. Since we don't have a high budget for our demo lab here, I used a slick piece of software by Starwind Software, based out of Massachusetts, that allows you to use internal hard disks in your Hyper-V servers grouped together into an iSCSI SAN. Make sure you download the PDF and follow the instructions closely. If you run into troubles, their support is really good. Next, you need to create the failover cluster by launching the Failover Cluster Manager from Administrative Tools. Then click on Create Cluster. Enter the fully qualified domain names of the Hyper-V servers you want to join the cluster. Give the cluster a name and an IP address, and make sure you check the box that says Add all eligible storage to the cluster. Next, you need to add clustered shared volumes to the cluster you just created. So, click on the cluster name in the left side navigation and then select Disks under Storage. In the event that your iSCSI volumes were not automatically added, you can manually add them by clicking on Add Disk in the right side navigation screen. Add your volumes and they will appear as clustered disks in the center screen of the Failover Cluster Manager. At this point, you need to do a right-click on each cluster disk and select Add to Clustered Shared Volumes. The clustered disk will now appear as a clustered shared volume. Once the failover cluster and clustered shared volumes have been created, you can create virtual machines that run on the cluster and use the clustered storage. To do this, you need to be using the Failover Cluster Manager. Click on Roles and then right-click to create your new virtual machine. Here you select the cluster nodes you want it to run on, and when it comes time to specify where to store the VM, you need to select the cluster storage volume that was created from the clustered shared volumes. The new virtual machine wizard should look familiar. It is the same one that we've been using all along. You need to specify whether it's a Gen 1 or Gen 2 VM, assign some memory, assign the networking card, and then connect the virtual hard disk. Again, make sure it is using the clustered shared volume from the clustered shared volumes. When complete, you now have a virtual machine running on a cluster using clustered shared storage. In this video, you learned about failover clustering and clustered shared volumes. In the next video, we will learn about the resilient file system. In the previous video, we learned about failover clustering. After watching this video, you will understand what the new resilient file system is. NTFS has been the file system for Windows for over a decade. Now, Microsoft is touting their new file system called Resilient File System. First, we will take a minute to discuss what the new Resilient File System is. Then we will talk about some pros and cons with the new REFS. And finally, we will show you a quick example of how to format a volume using REFS. Resilient File System is the next generation file system to replace NTFS. Key design advantages are automatic integrity checking and data scrubbing, protection against data degradation, built-in hard drive failure and recovery, along with redundancy. These are just a few of the new features available in the new Resilient File System. Let's take a look at some pros and cons. I think you'll find this interesting. The new REFS allows really large volumes of data to be created. It allows volumes up to 1 yottabyte. 1 yottabyte is 1 septillion bytes. Or if you think about it, 10 to the 24th power of bytes. Another way to look at it, a yottabyte is equal to 1,000 zettabytes, and that equals 1 trillion terabytes. That is a lot of data. REFS is also good at storing large volumes of data. It's good at maintaining data integrity. It has faster error correction and fixes data corruption on the fly. It's good at preventing bit rot, and it uses block cloning, which makes Hyper-V snapshotting and checkpoints a lot faster. It uses cluster bands to group multiple chunks of data, which is better for large data movement. And it's really easy to create new volumes as they get created a lot faster than they did with NTFS. There are some downsides to REFS. For example, Tribal Knowledge says it's not ready yet to take over for NTFS. You can't use REFS with clustered shared volumes. There's no way to convert an NTS volume to an REFS volume or vice versa. There's no file-based deduplication, no disk quotas, no object identifiers, no encryption, no named streams, no transactions, no hard links, and no extended attributes. With that said, you'll probably come to the same conclusion I have, is that REFS will be really great once it's finished. The new Resilient File System appears in Disk Management when you go to format a volume. In this video, you learned about the new resilient file system. In the next video, we will learn about live migration. In the previous video, we learned about the resilient file system. After watching this video, you will understand what live migration is. With all of this knowledge of Hyper-V, you are now ready to perform the arguably coolest feature in Hyper-V: live migration. First, we will take a minute to discuss what live migration is. Then we will talk about some scenarios where you can use live migration. And finally, we will show a quick demo of how to do a live migration. Hyper-V live migration moves running virtual machines from one physical server to another with no impact on virtual machine availability to users. As mentioned, live migration allows moving a virtual machine from one Hyper-V server to another. If your Hyper-V servers are clustered, then you must use the Windows failover clustering technology along with clustered shared volumes. If your Hyper-V servers are not clustered, then you must use the SMB protocol for your file transfers. To perform a live migration in Hyper-V Manager, click on the Hyper-V server, then right-click on the virtual machine you want to move, and select Move. Follow the wizard and watch your VM move from one Hyper-V server to the other. If your VM is running in a failover cluster, you need to use the Failover Cluster Manager to move your virtual machine from one Hyper-V host to the other. In this video, you learned about live migration. In the next video, we will learn about storage spaces. In the previous video, we learned about live migration. After watching this video, you will understand what storage spaces are. The last feature we need to cover for storage is storage spaces. First, we will take a minute to discuss what storage spaces are, and then we will talk about some scenarios where storage spaces can be useful. Storage spaces enables you to virtualize storage by grouping industry-standard disks into storage pools, and then create virtual disks called storage spaces from the capacity in the pools. Storage pools are the building blocks to storage spaces. You can mix spinning disks with SSDs. There are three formats for these disks: mirroring stripes data across the disks with one or two copies, parity stripes data and parity information across multiple disks, and a simple format just stripes data across disks without extra copies or parity. Storage spaces automatically repairs data on disk failure and provides continuous availability, integrated with failover clustering. Storage tiers allow you to create SSD tiers for fast data and use hard disk drives for slow data storage. It provides a write-back cache, and storage spaces are simply and easily managed from Server Manager and System Center Virtual Machine Manager. Also provides multi-tenancy using ACLs. In this section, we learned about storage virtualization, how to configure virtualized storage, IOPS and quality of service, multipath I/O, shared versus dedicated storage, failover clustering and clustered shared volumes, the new resilient file system, live migration, and storage spaces. In the next section, we will look at some relevant yet advanced topics. Hi, and welcome to Section 7 of Learning Windows Server Hyper-V 2016. This is the last section in this course, therefore we are going to cover some tangential yet important and advanced topics regarding Hyper-V. In this section, we will cover hybrid clouds using Azure and Hyper-V, PowerShell, and security. Now we move on to the first video of this section that deals with Azure and Hyper-V integration. After watching this video, you will understand what hybrid clouds are using Azure and Hyper-V. A hybrid cloud is a mixture of your own private cloud and a public cloud. Since Microsoft owns the public cloud Azure, it only makes sense to try to integrate your private cloud, that is your Hyper-V infrastructure in your data center, with the Azure public cloud. First, we explain what a hybrid cloud is. Then we describe Microsoft Azure and what it would look like integrated with Hyper-V. Then we go through some examples of how to create, build, and manage a hybrid cloud using Azure and Hyper-V. A hybrid cloud is a cloud computing environment which uses a mix of on-premises, private cloud, and third-party public cloud services with orchestration between the two platforms. Microsoft Azure has enough material for a complete course in itself, so I'm going to try to give you some quick tips so you can get Hyper-V integrated with Azure quickly. The rest is up to you. Before we get started, you need to know that there are two ways to get into Azure. The first one is using the Azure Classic portal, as seen on the screen with the bit link provided. The second way is using the new Azure portal, as seen on the screen with that bit link provided. You will need both of these portals to complete the integration process of Hyper-V to Azure. Aside from two portals, there are basically two methods to integrate your Hyper-V with Azure, using backup or site recovery, as seen on the screen in the new portal. You will notice that if you log into the Classic portal, it will refer you to the new portal if you are going to be using recovery services. So you should only use the Classic portal for help getting your account established and your Hyper-V servers integrated with Azure. From then on, use the new portal going forward. There are a couple of good resources to walk you through setting up a backup for Hyper-V to Azure. There are a couple of resources shown here in these bit links, and I'm sure you can find more online. For site recovery services, you can do it for Hyper-V VMs that aren't managed through System Center Virtual Machine Manager, and for Hyper-V VMs that are managed with VMM. If you connect to the bit link on the screen, it will take you to a page that describes all of the steps necessary to connect your Hyper-V servers to the Azure public cloud for site recovery services. First and foremost is you will need an Azure account, and you can sign up for a trial account if you just want to test it out. If you are using System Center Virtual Machine Manager, there is a way to connect it to the Azure cloud. If you connect to the bit link on the screen, it takes you to a web page that describes all of the steps necessary to connect your System Center Virtual Machine Manager to the Azure public cloud. You will need a self-signed certificate to connect VMM to Azure, and I've found a site that has been very useful for doing that. Here's the bit link to save you some time. To connect VMM to Azure, you will click on VMs and Services, then on Azure Subscriptions, and then at the top you will click on Add Subscription. Your subscription ID can be found in the Azure portal online, and this is also where you will need that self-signed certificate and its thumbprint. You will also notice that you can create a private cloud in VMM and create VMs on your Hyper-V servers, and they will show up in your private cloud. On the screen are some helpful bit links to refer to in the process of connecting your private cloud to the Azure cloud, whether you're using VMM or not. In this video, you learned what a hybrid cloud was using Microsoft Azure and Hyper-V. In the next video, we will take a look at PowerShell. In the previous video, we learned about hybrid clouds and integrating Hyper-V with the Azure public cloud. After watching this video, you will understand what PowerShell is with regards to Hyper-V. Arguably, doing everything through a GUI makes it simple and easy to learn how to manage Hyper-V. However, you can't build a large-scale Hyper-V environment without learning and using PowerShell. In some cases, you might find PowerShell easier and more flexible to use than a GUI. First, we explain what PowerShell is, and then we show some examples of PowerShell and PowerShell scripting. Windows PowerShell is an interactive, object-oriented command environment with scripting language features that utilizes small programs called commandlets to simplify configuration, administration, and management of heterogeneous environments in both standalone and networked topologies by utilizing standards-based remoting protocols. When running PowerShell, you will notice that it resembles a shell concept that was originally built for Unix or Linux systems. You open up a terminal or command line window in which you can enter individual PowerShell commands, a line of commands, or you can enter many lines of PowerShell commands that make up a script. The script can also be stored in a file and executed that way. There are a couple of different ways to launch PowerShell. First, from the GUI, and it's pretty simple. Click on the Start menu from the GUI and then click on PowerShell. You will notice there is an option for PowerShell ISE, which stands for Integrated Scripting Environment. In Windows PowerShell ISE, you can run commands and write, test, and debug scripts in a single Windows-based graphic user interface with multi-line editing, tab completion, syntax coloring, selective execution, context-sensitive help, and support for right-to-left languages. You can use menu items and keyboard shortcuts to perform many of the same tasks that you would perform in the Windows PowerShell console. For example, when you debug a script in the Windows PowerShell integrated scripting environment, to set a line breakpoint in a script, you just right-click on the line of code and then click on Toggle Breakpoint. Here are some other cool features. To run part of a script, select the text you want to run and then click on the Run Selection button or press F8. For context-sensitive help, highlight the commandlet and press F1. What if you are running Hyper-V without a GUI, as we've been doing throughout this course? You can still run PowerShell, but you get to it a different way. On the Hyper-V server, you see the text-based menu. Exit to the command line and enter PowerShell at the prompt. You are now running PowerShell on the Hyper-V server. To get to the PowerShell ISE environment, type in PowerShell ISE, and the integrated scripting environment launches. To get back to the menu, type in sconfig. Also now, with Hyper-V 2016, you can run PowerShell commands from inside of a virtual machine, making it easier to automate and script virtual machine management and configuration. For a list of PowerShell commandlets that are useful for Hyper-V environments, refer to the bit link on the screen. In this video, you learned about PowerShell and the integrated scripting environment. In the next video, we will take a look at security. In the previous video, we learned about PowerShell. After watching this video, you will understand what security for Hyper-V is. Although we have waited to talk about it, security for Hyper-V should not be an afterthought. If you've ever spent any time deploying anything into a DMZ or directly exposed to the internet, you know how quickly you can get compromised. First, we explain what security for Hyper-V entails. Then we show you some security best practices for Hyper-V. Security for Hyper-V can be a broad topic, but here are some areas to focus on. Hyper-V is a service that runs on Windows Server, so the best practices for security and hardening a Windows server apply to the Hyper-V host as well. Make sure you run Hyper-V Core, that is, without a GUI, to host the VMs, and then use separate Windows Server, as we did in this video series, with minimal components to use as a management server that runs Hyper-V Manager and/or System Center Virtual Machine Manager. Virtual machines are just servers without hardware, so you need security for these as well, according to the best practices for that operating system, whether it is Windows or Linux. If you are a service provider and will be creating multi-tenant infrastructures, you need a way to keep VMs, data, and networks separated from each tenant. Now that you have a private cloud with Hyper-V integrated with a public cloud such as Azure, how will you manage identities and access? Hyper-V uses Authorization Manager for role-based access control. For network security, the same concepts apply that were used in a traditional data center. However, now the network is virtualized. Don't forget to allow Microsoft updates to all of your virtual machines, as the updates often contain security hotfixes and updates. There are some security best practices for Hyper-V already out there. The ones on the screen, apply to Hyper-V 2012, but these also carry forward and apply to Hyper-V 2016. Follow the bit link and it will take you to these security best practices for Hyper-V. New for Hyper-V 2016 are shielded VMs. Virtual machines are stored in files, and these are open to attack. To protect against this, Hyper-V 2016 introduces the concept of shielded VMs. A shielded virtual machine is a Generation 2 VM that has a virtual trusted platform module installed, is encrypted using BitLocker, and can only run on healthy and approved Hyper-V hosts. A typical guarded fabric, if you will, consists of a host guardian service cluster, one or more guarded Hyper-V servers, and a set of shielded virtual machines. In this section, you learned about hybrid cloud integration with Hyper-V as the private cloud and Azure as the public cloud. You also learned about PowerShell and how flexible and useful it can be for Hyper-V. Finally, you learned about some security best practices for Hyper-V. I hope you enjoyed the course Learning Microsoft Windows Hyper-V 2016. We started the course with an introduction to Hyper-V and hypervisors in general. We then progressed to installing Hyper-V 2016, followed by installation of the most important pieces for managing Hyper-V, that being Hyper-V Manager and System Center Virtual Machine Manager. We did a deep dive on network virtualization where you learned about external, internal, and private networks and how to configure them in Hyper-V Manager. We took a big step after that and learned about direct access networks and virtualization networks using Virtual Machine Manager. We learned about memory and CPU virtualization, followed by storage virtualization. Finally, we showed you how to integrate Hyper-V with the Microsoft Azure public cloud to create a hybrid cloud. We then presented some tips on PowerShell and security best practices. Well, we've reached the end. This completes the Learning Hyper-V 2016 video series. It has been a great pleasure and a lot of fun guiding you through this subject matter. Thank you.